My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired.
Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GloCloud team.
Welcome back, everyone. Leo and I are here for actually day 8 of our completely free Google Professional Cloud Architect Bootcamp. Welcome back. Now, if this is your first day and you didn't realize about the previous 7 days, don't worry about it. My team is going to drop a playlist where you can catch the previous 7 days. And of course, you can watch today and then go back and watch the previous ones and go back to it as any number of times that you desire. So please keep that in mind if you just joined us or found out about it right now. Now, also, if you just joined us or found out about us right now, I want to let you know that there is a completely free study guide that goes along with this course. My team put it together based upon the materials that Alonzo and I created and Leo created for this course. So they created a really comprehensive study guide. It's about 550 pages, and it'll really help you pass that Google Professional Cloud Architect certification and that Google Professional Cloud Architect exam. So please sign up for that. It'll be emailed to you within 10 to 15 minutes. We want to do everything we can to help you. Tomorrow is Thursday morning. So Thursday, like every other Thursday, I run a How to Become an Architect webinar. And we talk about what we do as architects, the actual skills we have as architects, what we really do versus what people think we do, the actual skills versus what people train in and end up learning the skills for different careers. We'll talk about what it takes to be in the top 25% of the people that get hired and what those kind of skills are that you could use to improve your resume, to tune your portfolio, how to go market yourself, and all kinds of things that are going to be related to how to build an architecture career, regardless of where you come from. And of course, we'll be able to answer any questions you actually have about your career. So, or what you want to do, whether you're with us or not, we just want to help you. So join that free webinar tomorrow. Now, we're going to start off with some data warehouses. Data warehouses are everywhere. We're going to start off with some fun encryption. I always liked encryption. If you want to get real geeky on encryption, we've got some heavy-duty security certification stuff that gets geeky on encryption. I personally like encryption. I thought the concept of a hash and a one-way hash, I don't know when I saw it, and I'm not a math person, but I went, wow, this is cool. But that's just me, and I get, I don't know, I kind of like some of these things, especially that are I find them fun. So, it's going to be, but we're not going anywhere into anything heavy duty. This is going to be fun. This is going to be educational. It is going to be because it's going to be an architecture approach as opposed to designing heavy duty encryption systems. So we'll have some fun with it. We'll learn a lot. Leo, you've got a couple of labs today. You want to talk about what those labs are about?
Well, sure, Mike. Today we have one lab, and it's about PubSub, how to create a PubSub service, how to use a PubSub service.
Google PubSub sounds great. So, everybody, let me know that you're awake, you're alert and oriented. You know, I come from a healthcare perspective. When somebody walks in the room where somebody is not sure, we say, hey, you know, what day is it? Who's the president? You know, where are you right now? Those kind of things. So as soon as we see some, and also let me know where you're at. Let me know exactly where you're at. Let us know in the chat box. And then Chris, let's roll with the content. Now we're going to discuss data warehouses. And by doing so, we're going to discuss the Google data warehouse, which is called BigQuery. Now, BigQuery, truthfully, is an excellent data warehouse. Google's got a tremendous amount of experience in big data. Having said that, it's Google proprietary. So always things to think about. Now, BigQuery is very scalable and it's serverless. So you don't have to think about managing your servers when you're dealing with a BigQuery data warehouse solution. So it's designed to be easy to use for that reason. Now, it's also a petabyte scale data environment. So we can store, like I said, huge amounts of data in this. According to the exam, I should tell you that this is considered to be cost effective, meaning it would be cheaper than managing it on your own. That's always to be determined as you actually understand your usage patterns, etc. But, for the exam, think of it as cost effective. But, BigQuery is what you call an OLAP database, meaning an online analytical processing database that supports, standard SQL queries. So it's got that ability to run SQL type queries. Now, the reason that is, a lot of data warehouses are kind of like built off of, say, Postgres, for example. I'm not saying this is or isn't, but a lot of them are. And Postgres is a relational database that scales so big, for example, that people use it as a data warehouse. So I understand a lot of this is going to feel a lot more like an SQL database, typically speaking, than a NoSQL database. Now, if we think about what is a data warehouse, we're really taking huge amounts of information and storing it somewhere. And we're storing it somewhere so we've got the ability to do other types of analytics and thinking. So how do you typically think of these and how are they set up? So what you typically have are multiple data sources. And a data source could be a relational database. A data source could be some kind of streaming thing coming in, but you've got a data source. And typically we need to get that data into our data warehouse. So, we may have to pull or extract some form of a data from a different type of data environment. Now, when we think about a data warehouse, we think about structured data, typically speaking, whenever possible. So we typically use like an ETL tool, and then we put it into the database. So we extract the data, we transform it into whatever it needs to be to match the new database, and then we load it into the new database. Now, once that data is in this data warehouse, we can use business intelligence tools, for example, that can help us see better what's going on, which we can use to start thinking about what to do. We can visualize it and present it to the executives in graphs. So they have the ability to make better business decisions. We can make reports and get information. All of this is geared towards making better business decisions. That's the whole goal with any kind of these data warehousing environments. Better business information. We can take this data out of it, and then we can run machine learning on it and use AI to mine through the data. So there's a lot of things we can do, but we have to understand what the plan of the data warehouse is and how they're set up. And that's what we're talking about. Google's data warehouse is BigQuery. Think of it as a good solution for migrating if you're going from the on-premise data warehouse like Teradata or any other kind of good data warehouse. And then we migrated it over to Google, and Google manages it and runs it. But, think about, how many clouds you're using and what you might want to be using as well. So from an interaction perspective, users can interact with BigQuery through the Cloud Console that you're going to click on, the command line tool, the BigQuery REST API, or many other third-party tools. So we can run what's called the BigQuery job with regards to BigQuery. And BigQuery jobs are really are used to execute data loading, exporting data, querying data, copying data. And these jobs can run concurrently, meaning you could have multiple things going on at the same time and can be pulled for status updates. Now, we want to think about our data sets, and data sets are going to be top-level containers in BigQuery that will be used to organize and manage access to tables and views.
Now, the tables are going to consist in rows and columns, just like a relational database, and they're defined by a table schema. And the better the schema is designed, the more efficiently it's designed, the better the performance of the database will be. And we can set up views, and views are going to be virtual tables that will be based upon queries. So authorized views allow for sharing of query results with specific users. So, for example, we may not want a database to present everybody with the same information. We may want the CEO to get access to certain things that the average user doesn't, for example. So we can create various views so when people use the database, they can see only what information is necessary for them. Now, BigQuery, we can, in certain ways, partition the database. And by partitioning the tables or large tables, meaning making several smaller tables together instead of one huge one, we can optimize query performance. So we might split log data, for example, on a different partition than something else. Now, when we create partitions for the data warehouse, what we're really dealing with is we're going to create rules. And we're going to create rules that can be set, such as automatically deleting a partition or something that's older than 30 days. So maybe we put something in that partition that isn't data that we need long term. We put it in here and we create a rule that says get rid of it after this period of time, so we're not paying to store it. So kind of hope that helps. And we've got fairly fine-grained access here. The way these partitions can be set up, partitioning can help with access control as well to specific data sets inside of a table. So it allows different teams to query only what they need. And again, when it comes to security, the principle of least privilege, don't give people access to more than they need to be able to do their job. This is going to help here. And BigQuery is going to be powered by the Google-developed Dremel query engine. And it does allow for very fast query execution at scale. Google has a lot of experience in data. Now we're going to discuss Cloud Dataflow a little more. As I mentioned earlier, it was based on Apache Beam, and Dataflow is going to be built on Apache Beam. So it's going to offer a unified programming model for defining and executing both stream and batch data processing pipelines. Google would say it's a cost-effective solution because it's fully managed, and Dataflow handles all the infrastructure and optimizes performance and cost. So theoretically, it should be cost-effective for large-scale data processing. You can check that versus running servers in your data center versus running whatever servers you want on the cloud and make that determination for yourself. And you'll only know the real answer when you look at your specific use case and your data patterns. So where might we use Cloud Dataflow? Well, we may use them for stream analytics, and they're great for real-time processing of data streams, like fraud detection, personalization, and predictive analysis. Now, we might use it for real-time as well, and we might use it for fraud detection and real-time AI analytics. So we're making real information, and we may use AI to parse through that information and alert us when it sees things that are suspicious, for example. We might use Cloud Dataflow in an IoT environment, and it can be effective for, say, processing sensor data and log data from a large number of IoT devices, because you may have a fleet of thousands of them out there or more. We can use it as an ETL tool to extract data from a database, transform it, and load it into another database. And we can use it for data integration as well. So it can be leveraged for data integration tasks across various sources and destinations. So Cloud Dataflow provides some very fast streaming data analytics. So it gives us the ability to do real-time, low latency analytics for time-sensitive operations. Now, just think about in business, having access to data right now, know exactly what's going on, and be able to react to it in real time. The same way you would in a conversation. Someone says something to you, react to the conversation, and it flows. But if a business doesn't have a data, or it has old data, stale data, or incorrect data, it may make decisions that are not in that organization's best interest. So anytime we can get close to real time, it can be very beneficial. So what we're dealing with here is simplified data pipeline development, because pretty much what you have to set up is a pre-made product. You have to set up an input. Where's the data located? You have to talk about the data structure. What's the data look like? And there's a transformation logic where what actions need to be performed on the data. We need the data as what it is. It starts as this. What do we need it to look like when it comes out of here? And then you put the output destination, which is where do you want it to go? Where's the process data going to be stored at or set? So think of it this way. It supports real-time streaming and batch jobs, so Dataflow can efficiently handle both streaming jobs and scheduled batch jobs. It's fairly flexible. Now, when it comes to data analytics, Google has a lot of expertise in this world, lots and lots of expertise in analytics. So they have smart analytics solutions, and that's Google's cloud data analytics offerings, and they call it Smart Analytics Solutions. Now, Google, like I said, has tremendous expertise in data. World's largest search engine, the world's biggest search engine. The world's second biggest search engine. Think about the amount of data. Think about the number of YouTube videos that Google has. Think about the number of websites that they've indexed over the years. All the billions of websites, for example, that exist out there. Google has a tremendous amount of data. All the Google ads and all the information they collected to help you identify, to create an ad to the right person in the right area, looking for with the right background, interests, hobbies, and career goals. You get a lot of information. They have it. So they've been doing this big data thing forever. And Google's always recognized as a leader. Forrester Research found them as a leader in data management for analytics. But the key here is Google's always been a leader in big data. Now, Google's data analytics is cloud native, and it offers a cloud native analytics platform. So you don't have to think about dealing with all the infrastructure and patching and managing the infrastructure. And often this one stands out from competitors fairly frequently because they can scale so well, and Google has such expertise in big data. So tremendous number of use cases here for data analytics. But you think about taking large amounts of data and using AI or machine learning or business intelligence tools to gain things to help your business be better or help your client's business be better if you're an architect, for example, like a cloud architect. It's got a fairly large integrated ecosystem across the Google Cloud, so it integrates very neat with any other type of Google Cloud service. So ingestion, processing, storage, visualization. These tools integrate with Google's tools, and Google has a lot of tools here. Now we're going to talk about Cloud Pub Sub, and that is going to be a global message service to stage large event-based data for storing it, processing it, analyzing it. And it's a messaging system that guarantees at least once delivery. So that means that a message will be delivered to its destination at least once. And we'll support exactly once processing if that's what you want as well, to guarantee that it's only one time that it's been sent there. So when it comes to Cloud Pub Sub, there is no servers required because it's a managed service. It's going to scale automatically and add capacity automatically, so you don't have to think about capacity. It can be relatively high availability. Google says 99.9. I think it's 9.5 for this one. So relatively reliable. And it uses asynchronous communication. So publish, subscribe messaging is asynchronous. So that allows for a lot of scalability because it's loosely coupled. Where might we use Cloud Pub Sub? Log ingestion, for example. And that will enable multiple teams and applications to consume logs without needing to build custom data pipelines. We might use it for streaming IoT data because it's great for ingesting and processing large streams of data from IoT devices. We might use it for event notifications. So we can use Pub Sub for distributing notifications across services or systems. We might use Cloud Pub Sub for workload balancing, and we can help balance workloads across, say, various clusters in our system by distributing tasks or events to different services, so share across others. And it's asynchronous workflows, and that means if we put a message in the store temporarily, we don't have to necessarily deliver it instantly. So maybe if there's a slowness in the system, a bottleneck in the end system, we can store it and give it to them when it's ready. So the point is, it's not instant. And not instant also means more loosely coupled, which means more scalability. So there's some core components to Google Cloud PubSub. So the publisher. The publisher is going to be whatever generates the message and sends messages to a topic. And the message is going to be whatever the payload is. Now, the topic is going to be the resource that's going to represent a stream or a feed of messages from publishers. Now, a subscription is going to be the named resource that receives the stored messages from a topic. And a subscriber is the client or service that consumes the actual message. So I want to do that one more time because these things can get fairly complicated. In fact, what I'm actually going to do here is I'm actually going to give you visuals to help make this one easier to understand. So in this particular case, I actually want this to be in front of you so it's easier for you to see. So the publisher is going to be whatever generates the messages and sends it to the topic. You want now, which means what is the topic? The topic is going to be a named resource that represents a stream or feed of messages from the publisher. Now, the message itself is going to be whatever was sent, the payload. So that's what we're dealing with here. Now, a subscription is going to be a named resource that receives and stores messages from a topic until it's going to be consumed. And a subscriber is going to be a client or service that consumes the messages from a subscription. Lots of terminology on that one, so I wanted to give you something you could actually see. Now, when we think of Cloud PubSub, think that it's pretty scalable because it's going to be built on, infrastructure that's Google's own products that it's been using for a long time. Things like ads, search, and Gmail. So kind of think about that. So it can deal with a tremendous number of messages. It's a relatively versatile message solution, and then you can use it for real-time streaming, event-driven architectures, workload distribution, multi-team logs, for example, in lots of environments. Now, let's talk a little bit about data security. So cloud data security is a serious issue. At one point, organizations were afraid to move their data to the cloud because now in the cloud provider might have your data, be able to see your data, and or even steal your data. The reality is that when people use the cloud, they're at a bigger risk than in their data center. In their data center, to be attacked, you have to attack the company itself. In the cloud, you still have your same data center risks with your VPC, but now you have the actual risk of the cloud provider getting hacked and your information being taken. For example, with Microsoft Cosmos DB, Microsoft got hacked and then thousands of customers' data was taken that were using that same Cosmos DB. So there was always the concern about this in the beginning. And there still is the concern right now. So we have to think about understanding security. Cloud providers' default security mechanisms have become pretty good. And the reality is, for some reason, and I don't think it's necessarily correct, many businesses assume the cloud providers are better at security than they are. And in some cases, they actually are. And in some cases, they are not. So we have to understand now. So the majority of the problems in cloud are usually consumer errors, and it's usually from people that have a lot of certifications and have done a lot of hands-on labs where they know the name of something and they know all about configuring it, but they don't know what the technology is, how the technology works, why it might be needed, for example, and the impact of even using the technology. So that's usually where we're coming from with regards to cloud attacks. But you have to understand that it comes down to it. You've got a lot of attack vectors in cloud computing. Now, we talked about the shared security model, but it matters in data too. So cloud providers are going to constantly audit and maintain their security tools and typically be good. But if we make mistakes, for example, setting the wrong permissions to something in object storage, cloud storage in the case of Google, it's easy to get hacked because we don't have the boundaries we used to have, which I showed you in the beginning of this program. So we need to think about that. it is a shared responsibility model. So we have to understand that a lot of organizations trust the cloud providers, but they have to be cautious of what they're doing as well. So now we just have to think about whatever security implementations. Now, one thing we may need to do with regards to data is something called data classification. If you want to know more about data classification, we've got a completely free CCSP bootcamp on our YouTube channel, and that will deeply go into data classification for security purposes. But this is a Google Professional Cloud Architect exam, and that is far beyond the scope of this. So understand we may have to classify the data. And we can then apply access controls on our data. So if we classify the data at what it is, and there's going to be other tools that are going to monitor our data and data loss prevention systems, they can act on the data. For example, do not let secret or top secret data out of the organization. So we need to catalog the data, or at least, classify the data with regards to what it is. And that way it can support monitoring for data loss prevention, compliance violations. We typically want to label what we have. So let's talk about the role of data classification models. So data classification typically assigns a category based upon the data's type, sensitivity, and criticality. And organizations often use a classification mode to ensure that sensitive data is protected. So there could be 3 or 4 tools like public data, confidential proprietary data, and sometimes even some more sensitive. For example, you can think of very similar to the military may have open or secret or top secret or top secret, those kind of classifications. We're just dealing with protecting data based upon its sensitivity level. So it'll help us with regulatory compliance. So if we classify our data, that's going to be part of dealing with, say, GDPR or CCPA regulations. It'll make sure that, because many regulations talk about protecting sensitive data. So this will help us with that. So what kind of thing would go into data classification? Well, a lot of it has to do with data ownership. Who is the data owner versus the custodians? Labeling the data. So to be able to label the data based upon sensitivity and impact, like what happens if this data gets out, for example. The types of data, maybe we want to differentiate between structured data and unstructured data. Data life cycles, for example, from the time the data is generated to how long do we retain the data, to how fast do we dispose the data. All this is going to go into data security. For example, keeping data that we don't need but still has information on it means that if we get hacked, the exposure to data can be larger. And why are we storing data that's got no useful life for the business anyway? It's just enhancing our risk, enhancing our costs, and giving us nothing. Now, we typically want to monitor or have some kind of monitoring system to monitor for sensitive data. And we want to anonymize data, so to ensure that sensitive data is anonymous. So, for example, there's lots of ways companies, for example, do data masking, which is another way to protect their data. You may log into a website and all you can see is the last 4 digits of your credit card information. That's where they're hiding various kinds of data to make sure that if anybody saw what was on your screen, they can't access it because they've only got the last 4 digits of your card versus the entire 16 digits. So think about these types of things with regards to data. And you can't even track consent. So sometimes we need consent for data processing, and we can track that as well. So with regards to data migration, ideally before we get even send it to the cloud, we're going to do planning. So here's the best time to classify and identify our data and label the data before we even bring it to the Google Cloud. And by labeling it properly, it'll enhance our security, and it'll make it easier for our teams to detect non-compliance with a policy and then respond accordingly. Tools like cloud data loss prevention can detect, redact, or mask sensitive data. So masking data is where you hide some of the data, for example. Redact is when you make it impossible to see, and it can detect it. So we want to think about that. So cloud data loss prevention is a Google data loss prevention tool. understand that if you're multi-cloud, you may want to use a tool that works in all clouds. And there are some seriously great enterprise data loss prevention tools that we can use in our clouds. But I have to talk about cloud data loss prevention because this is a Google certification preparation for the Google Professional Cloud Architect exam. So cloud data loss prevention is going to help detect, redact, or mask sensitive data, things like social security numbers. And it helps protect sensitive data from ending up in public buckets or exposed locations. It is very important from a security architecture perspective to classify our data and organize our data and make sure that we secure our data. And it's much better to do it before you move to the cloud than after the fact. So cloud data loss prevention is going to be a Google fully managed service for data loss prevention, which is protecting your data. Maybe you protect data from leaving your system by monitoring it on the way to the internet. And if it sees sensitive data is trying to get to the internet, it can block the transaction. There's data loss prevention systems that don't let you plug in a USB port and actually pull data from a computer that's sitting in front of you. But we're talking about cloud data loss prevention. It will enable easy discovery, classification, and protection of sensitive data. And it focuses on de-identification of data. So it'll either mask the data or redact sensitive information whenever possible. So that's really going to protect your data because people won't have access to the full amount of data if the information were to get out. So key features of cloud data loss prevention are de-identification and the ability to make sure the data can't go be traced back to the original user or get rid of part of the data so that people that don't need access to the entire thing don't have access to it. It can scan the data, and it's going to consistently scan the environment and identify where data doesn't meet classification requirements. It's going to help classify data based upon the sensitivity and organizational rules. So all organizations are going to need some good form of data loss prevention. Now, let's talk about some limitations here. There are much more industrial-grade solutions. Many of them are applied to what's called egress monitoring, some of these industrial-grade solutions. So not only does it provide all these services we talked about, but if if you tried to send the data on the internet or someone did, they can actually block it. So you're typically going to get a more rich feature set from a more industrial tool. At the time we made these slides, it didn't provide egress monitoring with a Google solution. So think about more industrial solutions here. For both multi-cloud purposes and egress monitoring of internet and other things if you need super high security. So where might you use this cloud data loss prevention? You might use it to detect and de-identify sensitive data, like personally identifiable information within a large data set. You may use it to ensure compliance with data classification policies by scanning environments for misclassified or improperly handled data. You may use it to enhance data security by transforming sensitive information in a way that it reduces exposure and makes the risk of what happens if the data is exposed. So you can still keep the data and use it for all of its analytical capacities, but it protects you.
Okay, Leo and I are back. So we're going to have a very short video in encryption. If you desire to learn more about encryption, Chris or someone behind the scenes can drop a link to the CCSK, the Cloud Security Alliance's security boot camp that we did. You could also take the CCSP, which is a great cloud security certification if you're interested, and that's also available free. So Chris, please drop the links of those two free security courses, just in case somebody wants to get a little geeky in encryption. I don't think anybody will, but if they want to, I want them to have more knowledge about that over there. So when I asked you where you were from, I got a couple of answers. Let's look back and see what I saw. I saw London, which is terrific. Team Escalade, if I remember correctly, you're in South Africa, which is probably pretty cool. And I think, Jacques, you're somewhere in Europe, if I remember correctly. Barryman, I know you very well. Tom, it's good to see you back. Very good to see you back. So if you have any questions, let us know. Other than give me a hashtag Google Professional Cloud Architect. I think this kind of stuff's fun. Let me know it's fun. And Leo, you're going to have a lab coming up right after this video. What's that going to be?
The lab will be about using the Cloud PubSub There will be some buckets, some virtual machines, but the idea is creating and using the Cloud Pub Sub service.
Sounds fun. And Jacques, Little Rock, Arkansas. That's cool. For some reason, I don't know why I was thinking Europe. Maybe it was the French. All right, Chris, let's go with a little bit. Let's go with that intro to encryption, I should say.
In this video, we're going to discuss encryption, primarily encryption of what's being stored. And we're going to talk about some of the key management and encryption options on the Google Cloud, at least the ones that will be associated with the Google Professional Cloud Architect exam. So the first thing I want to do is kind of show you what encryption is and what it's for. So in this environment, we're going to use some encryption, and I wanted you to understand what we're doing and why we're doing this before we talk about other options. So here's an option. Let's say you had a critical meeting to discuss some incredibly important business information about a new product launch that could be, say, worth $20 billion. So huge scientific advancement. And let's say you needed to have a meeting, but you couldn't have anybody hearing the meeting, listening to the meeting, because there were proprietary things that were being discussed. So in this particular case, you would take a message and you would encrypt it and you would send it to the recipient. So, for example, we've got the one CEO that needs to make a meeting with an additional CEO or an investor or whoever they are. So the source of the message takes the message and they encrypt it, or scramble it, if you will, with an encryption key. Now, once that message is scrambled, there's no one that can access this message because it's scrambled and it's unreadable. And the only way to unscramble it is to have the key to actually decrypt the information. So we have a source. The source turns that message into gibberish, something that's not understandable by anybody. And then the key that's used actually unlocks it, so the recipient can actually get the message. Now, a lot of things typically happen with encryption. I can typically verify that the source and destination are who they claim to be because they have to have the key, among other things. And we can make sure the messages don't change because typically encryption has a hashing algorithm as well. Now, I want you to understand one challenge in this. So when we talk about key management, it may make sense to you. So we have a challenge of how do we manage these keys? Because if the wrong person gets one of these keys, well, then the next thing we realize is they've hacked into the system, and we could be talking to them when we don't want to be, and they can read our messages, which is a huge problem. So key management is going to become something important. Now, I also want to say, and it's far beyond the scope of the Google Professional Cloud Architect that has very intro-level security concepts in it, but there are ways where we can encrypt this with certificates versus symmetric encryption keys and asymmetric encryption versus symmetric encryption. And that is a really important thing to know about cybersecurity, but it's so far beyond what's actually in this program or in this curriculum or even in the Google Professional Cloud Architect exam. We're not going to cover it here. Now, if you'd like to learn a lot more about symmetric and asymmetric encryption and more things related to cloud security, we have a completely free CCSK bootcamp on this channel. We actually also have some other cybersecurity certification training like the CISM as well as the CCSK, and you can find them on our YouTube channel to help you understand some of these deeper security concepts. We have to understand that there's options regarding encryption keys. Now, the first option is to let the cloud provider manage your key, and that's going to be the default option. And interestingly enough, when Google manages your keys, it's also going to be the cheapest option. So let's talk about Google's default option. You know, they have a good key management system. It provides good, strong, scalable encryption, and it's based off of what Google's been using for years. Their default encryption includes AES 256, which means any data at rest will be using AES 256 encryption. Data is going to be automatically chunked, and each chunk is going to be encrypted with the data encryption key at that storage level. And the data encryption key is wrapped with a key encryption key using what they call the envelope encryption process to enhance your security. So All that really is you've got something wrapped in something else. We've been using this in networking and other concepts for decades. Now, this default use is fully managed. So they manage the keys, they rotate your encryption keys, keyrings, all that stuff is done for you by Google, which is really good because it minimizes your operational burden. It takes a fair amount of effort for key management, and this uses Google strict policies. And to be fair, the default encryption, the default options are good for the many, many organizations. But let's say we've got an organization that has mission critical security needs. Typically speaking, they can't use the cloud provider's key management system at that point, and they will have to manage their own. But right now, let's talk about the cloud key management system. And it enables you to manage cryptographic keys on Google Cloud. And realistically speaking, what we're talking about that, it enables you to generate, manage, and use the encryption keys protecting your data. But, if we think about that, that's standard. But what happens if you need something better, something stronger, for example? Well, then you can work with this environment where the customer themselves can actually manage their encryption keys. And in this case, with customer managed encryption keys, customers have full control over their encryption keys, and they can use that to protect their data. Now, interestingly enough, when you manage it instead of Google managing it, they charge you quite a bit for this each time there's a key. But if you need that level of control, then realistically speaking, you have customer managed encryption keys. Now, we can also use something called customer supplied encryption keys. And that basically, when we're dealing with customer supplied encryption keys, that allows customers to bring their own encryption keys and that are going to be stored outside of Google. So if we think about it, we're dealing with an external key management integration, and the key management system is going to be supporting connecting to that external key manager, which is what's going on with the customer supplied encryption keys. And that way, organizations have control over managing their encryption keys outside of Google, and then basically Google's using them. Now, we might need even greater security, and we might need a hardware security module to actually do for our encryption keys. And in this case, the Google Key Management System can actually integrate with Cloud HSM, which is going to allow keys to be generated and protected by FIPS 140-2 Level 3 hardware security. So some pretty good encryption there. And, let's keep it at that. So if we think a little more about customer managed encryption keys, customers are generating and managing everything. Now, that means incredible control over the key management process. If we go back to customer managed encryption keys, we're overseeing key generation. We're doing it all. Although when we get involved in this customer managed encryption keys, the customer is managing the keys. But Google is actually generating the keying materials. So let's talk a little more about customer managed encryption keys, just to make sure everyone gets this. It is really about strict key management. And we're going to use something like this customer managed encryption keys when we need strong audit trails. And that's going to allow customers to really monitor their systems and which users having service access to keys. Because the more we can see what's going on to our systems, the better our audit trail. We can enhance our security and we can enhance our visibility into seeing what's going on. Customer managed encryption keys, as I mentioned, can integrate into Cloud HSM, that hardware security module. And, when we're dealing with customer managed encryption keys, it's for organizations that really need enhanced control over their encryption keys for maybe compliance or security or audit. And if you're in one of those organizations where you need control over your encryption keys, you'll know it. And then this will be kind of mandatory for you. Now, if we talk about customer supplied encryption keys, that allows customers to bring in their own AES 256-bit encryption keys. And that way they have maximum control. Now, here regarding control and ownership, the customers retain full control over their encryption keys, making sure that nobody, even Google, has access to decrypt the data. So if we think about it, we started with default where basically Google manages it. The thing that we previously talked about, which was customer managed encryption keys, it's mostly the customer, but Google is still involved. But when we get into customer supplied encryption keys, now the customer is basically dealing with it all. They have full control over their encryption keys, and no one else has any knowledge. So we're not storing the keys on the Google Cloud either. And the keys will be purged after each operation. So we're going to do anything we can in this environment. Customer supplied encryption keys are going to provide maximum control and security. Now, when it gets to these customer managed encryption keys, it can be used in cases maybe where a government agency needs access, and Google obviously can't have access to top secret information. So it's not something that everybody does, but there are organizations that will need it. And it gets fairly complex, and that's why there's not so many organizations using it. But if you have really high security, the customer's going to have to manage their own encryption keys. Now, I want to talk about the external key manager, and that's going to enable organizations to supply and manage their own encryption keys. That is going to be supported when we need basically some external key management partner. Now, when we're dealing with this external key manager, there's no key storage in the cloud. Keys are going to be stored by a third party outside of Google's infrastructure, and that's going to ensure that the organizations have full control over the location, distribution, and access to the key management. So if we think, and that's one option we have. With regards to customer control, customers, typically own and control the key's location, the key's distribution, the key's access. And that makes this a very attractive option for organizations with strict security and compliance policies. Now, the external key manager is kind of addresses some of the challenges and limitations with customer-supplied encryption keys by being a little more flexible option for key management with enhanced control over encryption. So, this is sort of best suited for customers who require full control over encryption keys, with either EKM or the default option being the recommended option. So we're all dealing with what is the customer, what is their need, how strictly do they need to manage keys, and is the overhead worth it for them to do it themselves or let Google do it? Now, if you're in a highly regulated industry, you will be required to manage your own encryption keys, and that's what we talked about, the options to do so.
Okay, well, I hope you enjoyed that short video on encryption. As I mentioned, it was real short, so if you want to know a lot more, got that CCSK, you've got that CCSP, and lots of other fun security things, of course, on this YouTube channel, so go get them. Wanted to see if were there any questions that popped up. I don't think so, but see if there were any questions that popped up. And then, Leo, you're aware of what's next, right? Pub sub, right?
Yes, Mike, pub sub demonstration.
Okay, a pub sub demonstration. That sounds fun for me. And that's definitely something you'll find on that Google Professional Cloud Architect design, because it is a Google certification. So love that. So yeah, let me know you're awake. Give me a hashtag Google Professional Cloud Architect. If you just got here, please remember that we've got a companion ebook to go along with this course. And that you can just all you have to do is register. My team will drop the link in the chat box. And register, sign up, email, and you'll be emailed it within about 10 to 15 minutes or so. So that'll go along. As a reminder, if you just joined us tomorrow, we're going to have a How to Become an Architect webinar. We're going to talk about all the skills you need to be in a cloud architect, where you'll have to learn about what you need to, what you have to do, what you'll need to do, and to change your branding to the world, for example, to be seen as an architect. We'll talk about how and why you have to skip HR to get your first architect job, and you can't, because they'll auto reject you when you lack experience, but what you can do instead to get hired. So join us in the webinar. We can answer any questions you want, because we just want to help you. All right, I see some of these hashtags come in, and I think Anna that said you were in Argentina. Ever since my wife saw a video of David Guetta at this concert hall in Argentina, she's been begging me to go to Argentina. And if that happens, I can visit Leo on the way home, because he's not that far away, which is pretty great. And it's really wonderful to see that level where we know where everybody's coming from. So see the hashtags. I see you're paying attention. If you're having a good time, maybe give it a like. If you're not a subscriber, maybe subscribe, hit the bell to be notified of some new videos to really help you in your architecture career. And Chris, let's get back to Leo's content. Actually, Leo, just anything you want to say first?
Oh, just to prepare them for the demonstration, it's a little bit into event-driven architecture, right? So one action triggers another action, and we will have this pub sub service monitoring a bucket, an object storage bucket. And when a file or a picture is uploaded to that bucket, then the virtual machine will be triggered to execute some action.
Sounds great. All right, Chris, let's roll with this.
Hello. In this lab, I will demonstrate the pub/sub functionality. I will start here at the page cloud.google.com, and I will use the search functionality and enter pub/sub. The first link here is what is pub/sub. I will click this link. After clicking that link, the what is pub/sub page is displayed. Pub/sub is an asynchronous and scalable messaging service that decouples services producing messages from services processing those messages. So we recommend you read this page to understand the pub/sub functionality. How it compares to other messaging technologies such as Apache Kafka, the comparison service to service and service to client, some integrations, and some next steps. Here from the left side menu, from the Get Started section, I will click pub/sub Service Overview. This opens the overview of pub/sub service page with a diagram explaining the pub/sub service and more information about the life of a message, the status of messages, how to choose a pub/sub publish and subscribe pattern, how to choose a configuration option, how to set up pub/sub, some guidelines, and here from the What's Next session, I will click the link to quick start publish and receive messages in pub/sub using the Google Cloud Console. This opens the publish and receive messages in pub/sub using the Google Cloud Console page. Here there are some instructions and a step-by-step what you need to do using the console to create the pub/sub functionality. And the first one is to set up a Google Console project. I will switch here to the Google Console tab. And here on the top, I see the project that is selected. In this case, it's called My First Project. I will click this button or this option. And then here I have an option to create a new project. I click New Project and I give a name to this project. And then I click Create. Now the project is created. I can select it. And one of the first things we need to do when we create projects, and most of them use virtual machine, is to enable the Compute Engine API. And here also is the instruction to enable the pub/sub API. So let's go back to the Google Cloud Console here. And from the top left menu, I will select APIs and Services and enable APIs and Services. From there, I can type here Compute Engine API. Click Enable to enable that API. And while this API is being enabled, I will duplicate this page. And I will go back to the Enable APIs and Services. And I will look for PubSub API. Cloud PubSub API. And I will click Enable to enable this API as well. Now the Compute Engine API is enabled, and so is the Cloud PubSub API. Going back to the instructions, the next section is to create a topic. So I need to go to this PubSub page, click Create Topic, give a name to the topic, and then click Create. So let's go to the top left menu, and if you can't see the PubSub or how to find the PubSub, you can click View All Products, and then you can type here. So, and here I will click the Topics PubSub. And now I am in the PubSub Topics page. I can click Create Topic. As per the instructions, I will call this My Topic. And that's it, and click Create. From the documentation, the next step is to create a second subscription. So I go to the PubSub subscriptions page, click Create Subscription, enter name, select the topic I have just created, and then click Create. So to the subscription page, click Create Subscription, enter the name of the subscription, My Sub, select the topic just created, and click Create. The next step is to publish a message to the topic. I go to the PubSub Topics page, click the My Topic, then click the Topics page and click My Topic. It's kind of duplicate. But click the Message tab and then click Publish Message. In the message body, enter Hello World. So I will copy the message body here, go to the Topics page, click My Topic. From the Message tab, click Publish Message. And then from the message body, I enter Hello World and click Publish. The next step is to pull the messages from the subscription. So I go to the PubSub subscriptions page and then I'll click Pool. So from this subscriptions page, I click the subscription, and from message, I click Pool. The message will appear here, Hello World. This is the basic functionality of the PubSub service. You create the topic, you create the subscription, you publish messages to the topic, and then you pull the message from the subscriptions. There are different use cases for this functionality. I will just elaborate a little bit on this demonstration just to show a practical example. It will not be a full example, but it will be enough to understand the functionality. I will go back to the subscriptions page. I will click to select all subscriptions and click delete because I will not use these subscriptions anymore. And I will go to the topics page. I will click my topic and then click delete because I will not use this topic. I need to type delete and click the delete button to confirm I want to delete the topic. Now I will go back to the API and services again, because for this demonstration I will use two buckets. One bucket will be the input bucket. I will create a PubSub topic that will receive a message whenever a picture is saved for the input bucket. A message will be published to the topic. I will also have a virtual machine running a Python application. This Python application will subscribe to the subscription of that PubSub. Whenever a message is published to the topic, Python will keep looking on the subscription, trying to get to pull the message from the subscription. Whenever Python is able to pull a message from the subscription, it will get the name of the picture that was saved to the input bucket, and then Python will resize the image and save the new sized image to the output bucket. So the PubSub will monitor the input bucket and post message to the subscription, so the Python application can pull the messages from the subscription to do the logic. For this, I will need to enable the cloud storage or object storage API as well. Here is the cloud storage API. It seems to be already enabled. Since all APIs are enabled, I will create a service account. So from the top left menu, I'll go to IAM and admin and then select service accounts. I will click create service account and I will enter a name for this service account. I will paste the name here. Image processor service account. And I click create. And then from the grant this service account access to project, I will select 3 roles. Storage object admin. Let's find storage, cloud storage here on the left. And from the right, storage object admin. Storage object admin. I'll click add another role and I will look for PubSub subscriber. I click it and I click add another role and I will enter monitoring viewer. So after selecting all three roles, I click continue and then I click done. Now I will use the top left menu, select cloud storage and right click on buckets to open it to a new tab. I will switch to that tab, click create bucket, and then I will enter the name of the bucket. I will call it picture input. Click continue. That bucket name is taken. I will enter some numbers here to try to make it unique. Okay. I will select the location type as region and click continue. I will accept the standard for the how to store the data and click continue. From choose how to control access to objects, I will simply change for fine-grained. Click continue. I will uncheck the soft delete protection for the data. This is just a demonstration for a real case scenario. Please make sure if you need or not soft delete protection. And then I will click create. And the enforce public access prevention is selected and I receive this warning. I confirm I want this bucket to be private. I will go back to the bucket list and click create again to create the picture output bucket. Let's see if the name is unique. I will select region and click continue. I will accept the standard storage tier. I will select fine-grained and click continue. And I will uncheck soft delete and click create. I will receive the warning and I will confirm I want this bucket to be private. This scenario where my buckets are private is a use case that you have your private system, you want to do something, some action on the data, on the files that are uploaded to the bucket. In this demonstration, I'm resizing images, but in another use case, it could be to run an application to process some data, some PDF, some spreadsheets. In this case, the application will only resize the pictures that are uploaded to the input bucket. Now I will switch to the PubSub page, and from the topics, I will click create topic and enter a topic ID like image resize topic, for instance. I will uncheck the first option here to add a default subscription to this topic. I don't want a default subscription. And then I click create to create my topic. Now I'll go to the subscription page, click create subscription, and then the subscription ID will be image resize subscription. And here I can select the topic this subscription is related to, is the topic I have just created, image resize topic. And I can scroll down and click create. So now I have the two buckets and I have the topic and the subscription from the PubSub service. I need now to connect the bucket with the PubSub, with the topic. For this, I will need to open the Cloud Shell. Is clicking this icon here on the top. It will open a terminal. I need to authorize it, and I will close this. And I will bring the command that I need to run in this terminal window. This is the command. GSUtil is the name of the application that will run this command, and it will run a notification, or it will create a notification for one specific topic, so that this topic is notified from activities that happen inside this bucket. So here I will enter the name of the bucket I created. That is this one. I will just copy to avoid any typos. So a notification will be created connecting this topic to this bucket. And the notification will be triggered every time a new file is uploaded to the bucket, as one of the actions this notification will monitor. And I got a bad request exception. You have passed an invalid argument to the service. Your project ID. Oh, right. I need to enter the project ID here in this command as well. I will bring the command back to the prompt, and from when I open the list of projects here, I have the project ID to the right. So I can copy the my PubSub project ID from this window, go to the terminal, position the cursor where I will paste the name or the project ID. I remove this text before and paste, and then I paste my project ID here, and then I can execute the command. And the response I got was created notification. So this is okay. Now I have a notification connecting the bucket with the topic of the PubSub. I need now to create the Python application to pull the messages from the subscription related to that topic. I can close this Cloud Shell now and use the top left menu and open the Compute Engine VM instances in another tab. I will switch to that tab I just created and click Create Instance to create a virtual machine. I will use the name for this virtual machine as Image Processor VM. And I will accept this region, US Central 1, and select the US Central 1A as the zone for creating this virtual machine. I will click from the left side menu, the OS and storage page, to change the default Debian GNU Linux version or image to an Ubuntu image to create a virtual machine based on Ubuntu operating system. And I will select the Ubuntu version 24.04 LTS. Click Select. From the networking part, I will select Allow HTTP and HTTPS traffic. And I will go to the Security tab, and from the service accounts, select the service account created with name image processor service account. From the access scopes, I will select allow full access to all cloud APIs and then click the Create button. After several seconds, the virtual machine is ready. I can click SSH to connect to the virtual machine. I need to authorize the SSH connection to the virtual machine. And here is a quote from inside the virtual machine. Since this is a new Ubuntu installation, I will do a sudo apt update and also a sudo apt upgrade -y. This is basically updating the operating system itself to the latest packages available. The next command will install Python and some dependencies. So sudo apt install Python 3 -pip, which is the package manager for Python. I will install those two. I answer yes to the question if I want to continue by clicking the Y key in the keyboard and pressing enter. Now I will verify the exact version of Python that was installed, and it was the version 3.12. And now I will install sudo apt install Python 3.12 vf This is a Python application to create virtual environments and isolate the code into a virtual environment. After installing the Python applications and dependencies, I will create directories to contain the code of my application. So I will create mkdir is map directory is to create a directory which is called image processor app. And I will change to that directory. And now I will use the Python 3 VMF application to create a virtual environment inside a folder called VMF. So this is issuing the VMF application, and this is the name of the folder or directory I want to create the virtual environment inside. Now I can, if I list the content of this folder, we will see a VMF directory there. And now I can activate the virtual environment. So I enter source and then the name of the directory. This is actually an application inside that directory. If I list instead, if I list the VMF bin directory, we will see the activate application inside that folder, and then I can run source to activate that virtual environment. And when the virtual environment is activated, the name of the directory which contains the virtual environment appears here at the beginning of the prompt. Now I need to install some applications using Python package manager, which is pip, and the command is install, and the name of the packages are Google Cloud Storage, Google Cloud PubSub. These are the two applications or interfaces Python you need to interact with to do what is needed. Now comes some libraries from Python which will deal with the action the Python will take. Below will resize is the library that resizes the picture. And I believe this is it. I hit enter to install those applications. Now I will create the Python application that will resize the image. I will use a nano text editor, in the file name that nano will create is called processimages.py. Now the text editor is open. I will bring the code from an external application. Here at the top, it's basically importing some libraries that Python or this application will need to use. And here are some variables, or better saying, constant definitions that are being created. The first one is the project ID. So I need to replace this text with my project ID. So I will get from the Google Cloud Console the project ID again to my PubSub projects. Let me select the full name of the ID, copy, bring the SSH window back, and remove that text and paste my project ID. The subscription ID, image resize subscription. I will just make sure this is image resize subscription. The next one is the input bucket name. I will get the name of the bucket from the bucket list and add here, remove the text and paste the bucket name. And the next one is the output bucket name. I will go back to the bucket list and copy the name of the output bucket. Bring the SSH window back. Remove the text and enter my output bucket name. This is all you have to replace, to customize, to create the constants here at the beginning of the file. Here is also defining how many pixels for the width of the resized picture and how many pixels for the height. You can change this to create the image for the size you want. Here is the subscriber. Python is using that Google Cloud PubSub application to subscribe to the PubSub topic. And here is creating some links with the storage bucket and the subscription path. Here you see project ID again, but you will not replace the project ID here because this is the name of the constant that was created before. The same is valid for subscription ID, is this constant which already contains the name of the subscription. And here there is a function that actually receives the picture and then resizes the picture. And then it verifies what is the extension type of the picture. And later it will save the picture in the output bucket. I will hit Ctrl X to exit. I will confirm yes, I want to modify the buffer, and it shows the name of the file, and I press enter to confirm I want to save the content of the text editor to the process images.py file. Now that I have the application, I can manually run this application again. This is a demonstration. I will run the application from an SSH window. Whenever you close this window, the application will stop running, even if the virtual machine is still running. In production, or if you are creating something that you want to keep running, don't execute manually. Use some system level application to run the application and keep it running even if you close the terminal window. So here I'm using Python to execute this script, this Python script, which is the one just created in the text editor. To test if the application is running, let's go to the input bucket and let's upload a picture to this bucket. I'll select this first picture here, click open, and bring the SSH window back. And I was expecting to see some messages here inside the terminal. Let's see inside the output bucket if any output was generated. And here we have the resized Go board overhead. And going back to the SSH window again, there is no message. So the application is running, but it doesn't show any messages here on the terminal. I will go to the input bucket again, and I will upload 2 files. Let me see if I can select 2 files. No, let's upload this one, checkers. And then let's upload chess. And let's check the output folder. Let's refresh the output folder. It shows the information on this page is out of date. Refresh to see the latest data. I will click refresh here, and there are the checkers and chess resized pictures. So this elaborates a little bit more on the pub/sub demonstration, just to put in a context of some actual application doing or executing some actions based on the pub/sub topic. The pub/sub topic was connected to the input bucket. So every time a picture was uploaded to the input bucket, a notification would be sent to the topic of the pub/sub service. That topic will publish the message on the subscription, and the Python application from time to time checks the subscription and pulls the message from the subscription. And when new pictures are uploaded to the input bucket, Python receives those messages and then can do the action the script was programmed to do. To clean up this demonstration, I can select all the buckets and click delete. This will delete all the items inside the buckets. I need to type in delete here and click the delete button to delete the buckets. I can go to the subscription and select the subscription name and delete it. Then I can go to the topics page and select the name, click delete to delete the topic as well. I need to type in delete and click the delete button. And then I can go to the virtual machine. I will cancel this here. I select the virtual machine and I click delete to delete the virtual machine. And the last item to delete is the service account. I select the image processor service account and then click delete. Delete service account. And I click delete to confirm I want to delete this service account. So now I have deleted all items that I used in this demonstration. The virtual machine is still being deleted. But this is how you do the cleanup after you use the pub/sub topic and the needed services or applications that were created to do this pub/sub exercise. In this lab, I used the pub/sub service to monitor an input bucket or object storage bucket. Whenever any pictures were uploaded to that input bucket, a notification will be sent to the pub/sub topic, which will publish a message in the subscriptions where the Python application running in a virtual machine would pull the message from the subscription and then do the action the script was programmed to do. After demonstrating this functionality, I did the cleanup, deleting all the services and applications used in this demonstration. Thank you for watching and see you in the next lab.
Okay, Leo, thank you for that. That was kind of cool to watch. I had fun watching it. So we wanted to check in to see how everybody's doing, see if anybody had any questions that popped up along the way. What we're going to be talking about next is going to be monitoring and logging. And then we're going to get into automation. And then there's a small percentage of DevOps that's on this exam. And we're going to start getting into that. And then a little bit of operation. So that's where we're headed. Check and see if anybody had any last questions. And if the answer is no, just give me a hashtag Google Professional Cloud Architect and we'll start moving. Lots of fun stuff today. Lots of chances to get, I think it's kind of cool to get geeky on these things. I don't know. I kind of like tech. It's just been my hobby for the last 30 some years. I want to remind everybody that lots of time YouTube just signals people and you just join and you might find that it's day 8 of a Google Professional Cloud Architect Bootcamp, and don't worry about that. So here's the thing. If you just got here, my team is going to drop a link to the study guide. Go click and register for the study guide. You'll get emailed this 550-page guide to help you prepare for the exam. My team made it. It's completely free. And of course, my team is going to drop a link to the playlist in case you just found this. You can go back and watch the previous 7 days because I want you to have the opportunity to go through this once, twice, and then go past that Google Professional Cloud Architect certification. I think you'll do really well on it. So that's where I want to say for that. Keep that in the back of your mind. And of course, it's Thursday tomorrow. And on Thursdays, we do How to Become an Architect, where we go over the architect role, the architect skills, what we actually do as architects versus the things that people think we do. So you don't spend 5 years learning the wrong skills, which sadly happens all the time. I'll answer questions. You want to check and see if you're ready. I'll give you a mini interview. You want me to check your competency? I'll find out. You want a recommendation? I'll ask you whatever questions I need to ascertain the information to do that. And it's completely free and it's live on Zoom. So my team will drop the link for that webinar. And let's go back with the content. I see you're awake, alert, and oriented. It looks like people had a good time with Leo's labs, but there's no questions that popped in.
Now let's discuss monitoring and logging on the Google Cloud, which is obviously part of the Google Professional Cloud Architect curriculum and exam. So let's discuss what is monitoring and logging. So we have to monitor the systems to make sure they're up and they're healthy, because we don't want to find out that we're not selling something on our e-commerce website because something was down and we didn't know about it. So there's management systems that we can use that are going to be constantly checking the health of the routers and the switches and the servers and anything else that's placed on a network. And there's other ways to monitor applications and other things. So we're going to be constantly monitoring the health of the system, the performance of the system, and the uptime of the system. Now, while we're doing that, we also want to collect information that's going on that we may not see just by looking around if something's up or down. Now, most systems generate logs. In fact, if you look at your system's logs, you'll see all kinds of things. A new thing was installed, a new thing was removed. This memory thing had a problem here. This application crashed. And you'll get a lot of information. Or the system has a firewall on it and someone's trying to breach the firewall, and you'll get firewall denial logs. So the point is as we look through the logs, we get an incredible amount of information as to what's going on, which can also help us monitoring it. Because if we can see certain things and then we can do certain things, well, then we can get into incredible things. Okay, so let's talk about monitoring and logging, how they could be used together. And then we'll show you how it's done on a modern basis. So let's say we've got a monitoring system. And the monitoring system is checking on where your systems are. Let's say your systems are here. So this will be checking your systems, and it's constantly checking what's going on. And if everything's good, you get happy and healthy messages. Now, these systems themselves are going to send a tremendous amount of logs. So all of these systems will be sending logs. You could be getting VPC flow logs, or some equivalent of that, which tells you what your traffic is going through, which things are blocked by an ACO, which is not. So these systems are going to generate a huge amount of logs. So typically what organizations do is they take these system logs, and they're going to be coming from multiple cloud. And then what they do is this: they take the system, and then they send they create all their logs to wherever they're logged in Google. And then what ultimately happens, because they could be logged in, say, let's say these are Google logs. Let's say while we're at it, we've got some Microsoft logs. Let's fix that. We're going to have other logs too. And what we'll do is we'll send them to a SIEM system, or a security event monitoring system. And what can happen is these SIEM systems over here, they have AI. And what they can do is they can look at all these logs in real time, and they could see, wait a second, there were some changes over here in the logs. And this thing was a log on the firewall. This was a log on the IDS IPS system. This is a log in an ACL. Maybe we're being hacked, and can we do something about it and fix it immediately with AI? Or can we send a message to somebody to fix it as well? So organizations will constantly be logging to keep what's going on, but monitoring, they'll also be monitoring as well. So I just want you to understand the point of the logs. So when we talk about logging, understand that it's going to capture records of systems events, applications events, and this is going to be incredibly useful for troubleshooting, because we can see a bunch of things that happen in the log, but it's also going to be critical for security. We can use it to make sure we're not being hacked, for example. So logs give us a lot of information. Logs give us the ability to identify potential issues, tune and optimize performance, maintain compliance, because it gives us visibility into what's going on. And Google has cloud monitoring and cloud logging, and we'll talk about that to provide integrated solutions to help you observe, analyze, and respond to events effectively. Now, of course, you might have systems work together for all your stuff. So let's talk about some key components of monitoring and logging. In monitoring, we're really focusing on tracking and analyzing the performance of something. Things like, is the CPU 90%, or is the CPU coming comfortably along at 60%? Are we almost out of DRAM, or is there plenty of DRAM to go? Is that network becoming a throughput limitation, that network port, or is it not? What's going on with the disk I/O? Performance is slow. Do we not have enough IOPS? And if so, what do we need to do about it? So that's why you're going to be monitoring your systems. And this typically integrates fairly well with Google services and even external systems, but it's going to work very well for Google services. Now, logging is going to be more about capturing detailed records of events that have occurred inside of something. So these logs are going to be critical to diagnostic events, security events, understanding application behavior, auditing user activity. So the logs are more comprehensive and detailed versus monitoring is more real time to see what's going on. And Google has a cloud logging, which is going to provide a centralized solution for collecting, storing, and even querying or looking at your logs from various sources. So logs can either be filtered or analyzed or whatever you need to do to pinpoint issues or track things, including compliance-related activities. So if we talk about cloud monitoring, it's a Google fully managed solution that tracks the performance of systems. There's other non-Google packages that do this as well, but that's the Google managed monitoring system. It collects metrics of your on-premise stuff, your Google Cloud stuff, third party. But remember, that's more of like, what's the CPU like? How well are things working? And that can give you like a real-time dashboard, which is going to give you integrations with tools like PagerDuty, Slack Cloud, and that's going to enable you to monitor things, so minimize downtime. So it's pretty cool monitoring. They often used to call this systems management, where you can monitor and actually change something at the same time. Now, let's talk about logging. I want to talk about it more. I know we both talked about it, so I introduced the concepts, and then I like to talk about it a little more to make sure everybody gets it. Logging is getting logs from like everything we can. And really collecting these things. And allows users to create log-based metrics. And so we can really find out exactly what's going on. We can get very detailed in logs. And detailed logs gives us a very deep understanding of what's going on. And because there are logs, and cloud logging can actually be exported to BigQuery, which is pretty great because you take your logs, now you put it into a data warehouse. Now you can start thinking about some advanced analytics and maybe some AI or machine learning to go mine through those logs. And this is really great to enable teams to identify trends, predict failures, and optimize system performance. Now, we also want to talk about error reporting. And error reporting in Google Cloud is going to be a specialized tool for identifying and managing application errors. It's going to automatically detect errors from logs, aggregate them into something meaningful, and provide some detailed stack traces for debugging. Now, this will be great because it'll enable developers to quickly understand and resolve issues in their applications. Error reporting integrates with cloud monitoring and cloud logging, and that way it creates a fairly cohesive system for tracking and managing errors across our applications. So, fairly good tools here. Now let's talk about alerting and notifications. When we're dealing with any of these features of monitoring and logging, maybe we'll want to know if a system's too busy. Tell me when the CPU is at 93%, for example. I want to know these things, especially if we don't have an auto-scaling policy on something. I want to know these things. I want to know if my servers are overloaded, generally speaking, where they're going to be sluggish, where I either need to add capacity or use a bigger server. I want to know these things ahead of time, or multiple bigger servers. So we can actually set up messages to alert us. And by doing so, we can get a Slack notification or a pager or a text message or something that says, we got something going on, go fix it. So we always want to have system alerts. Now, generally speaking, system alerts can often be fanned out into other things and other tools that can also help as well. So one of the things that is really great with Google Cloud Logging is you can export the logs directly into BigQuery. Because it's integrated seamlessly, you don't need to think about any kind of tools or any kind of thing that you might need to do it. It's just there, which is pretty great. So now you can run SQL type queries on the logs, generate reports based upon the logs in a in a data warehouse, And you have your information in a data warehouse. Now there's tools to visualize that data. So we've got a lot of good benefits by taking these logs and integrating them into BigQuery and then using some AI tools to really see what's going on. Now, we can do that with monitoring, logging. We can also be using SIEM systems that do a lot of these things as well. Now, let's talk about why it matters. So certain industries are regulated. For example, healthcare has HIPAA regulations. Europe has GDPR regulations. We've got SOC 2 and other types of compliances. And that means there's a lot of information in the log. So in order to stay this, we're going to need to collect a lot of logging and auditing information. But at the same time, we want to keep it encrypted. So we have to understand the industry. Some industries need to retain their logs for 7 years. So we also need to think about where we put these logs for this period of time and how do we store them affordably. Now let's talk about something called application performance monitoring. And application performance monitoring really involves tracking metrics like latency, error rates, and throughput. And by tracking these kind of things, we can make sure that the applications perform well and give the user a great experience. And Google Cloud has some monitoring tools and logging tools that are really going to help you get there. It'll help you find those systems bottlenecks. And when you know where the bottlenecks are, then you're not guessing, I think it's this, I think it's this. You've got data to make data-driven decisions. And with regards to monitoring, if and when an incident occurs, or a security incident, or somebody makes a mistake, we need to know what happened. And usually mining through the logs gives us a lot of information. This thing happened on the firewall, then this thing happened on the IDS system. This blockade, somehow there was a lot of block packets going on to, for example, the load balancer, and based upon a security group, and whoops, or an access list or a packet filter or whatever we're dealing with, and whoops, okay, we've got something we need to worry about. Now, what is the incident? How do we respond to it? And what do we do? And that's really going to depend on the organization's incident response plans, incident response teams, and how well that was orchestrated. And that's a key component for security architects, obviously, is creating these business continuity plans, disaster recovery plans, incident response plans, etc. And to see if anybody has any questions. If there are any questions, we'll be able to address them, and then we'll, of course, go back into the content. But did it look any questions pop up? Rohit, is this course required to be attended? You are more interested in AWS. So Rohit, you can attend what you want in life. You can apply for any job you like. You can train for any job you like. So there's nothing that's absolutely required. I will tell you this, Rohit. If you just know AWS, there's going to be no jobs for you in the entire world. 98% of organizations are multi-cloud. And that means if you know AWS, only 2% of the people that are out there, companies that are out there, could potentially hire you, and the other 98% couldn't. So when it comes to learning cloud, and I think you might actually be in our architect program, the key is to learn the cloud, learn how to do what you need to on the cloud, and then not worry about the cloud provider. So if you're training with us, you're going to learn all clouds, and you only need to get certified in one of them, either the AWS Solutions Architect Professional, the Azure Solutions Architect Expert, or the Google Professional Cloud Architect. But if you're not with us and you're not being taught cloud computing and you're not being taught data centers, I would strongly recommend learning more than one cloud, and actually learning the cloud versus any cloud provider in general anyway, because the key is AWS is a vendor. And that's kind of like saying if you wanted to be a driver to drive across the country, for example, I can drive a Mercedes. I'm certified in how to drive a Mercedes, but I can't drive a truck. I can't drive a van. I can't drive a car. I can only drive a Mercedes. So keep that in the back of your mind. But honestly, nothing is required. You have to find out what your goals are and what skills you do. I recommend, if your goal is to be a cloud architect, train to be a cloud architect, and then get one certification in the cloud. AWS Solutions Architect Professional, Azure Solutions Architect Expert, Google Professional Cloud Architect, get one of them, and then get another in, say, TOGAF 10, and then get another as a CISSP. But as per which cloud you certify on, it really doesn't matter. Pick the one you want. I just want to make sure you have skills across clouds, and that way you'll be good anywhere. Your name looks familiar, so I think you'll have access to your training with us otherwise, but I'm not 100% sure just being live like this.
but your name looks real familiar. So hope I explained that in a manner that makes sense. If not, please ask. So Chris, I don't see any other questions. So we're going to get into the next content. We're going to have a little fun with this. We'll have a little more to go. And then after that, we'll be back in a few minutes to answer your questions. I want to do anything I can to make sure this is a great experience in this Google Professional Cloud Architect certification. And Rohit, I hope I answered your question. Now we're going to discuss automation and some DevOps concepts. And DevOps isn't really architecture, but it's very critical to cloud computing. So we're going to talk about it. And it's very critical to speeding up the velocity that applications are deployed, which we'll talk about that as well. So anytime it's possible to use automation to streamline repetitive tasks and infrastructure, it's a good thing. And it's a good thing for a lot of reasons. One is to decrease the organization's cost to do basic normal things, which means that reduces cost. It also reduces the chances of manual errors and human error along the way, which means greater quality as a general rule. And if an organization's people aren't worried about, menial tasks that can be automated, then they can focus on bigger, more high-value things that'll do better for the business. So that's the whole point of automation in DevOps, is to really streamline operations, make them faster. And DevOps is also about, breaking down silos, just like architecture is about breaking down silos. DevOps is getting the developers and the operations people together so they can do things better and faster and cheaper as a rule. So DevOps can greatly enhance productivity. For example, we can have a single DevOps engineer with an infrastructure as code script launch an infrastructure that may have taken 50 or 100 people a week or two or a month, and it can all be done in seconds with a DevOps engineer. Now, granted, it may have taken a little bit of time to break that infrastructure as code script, but if it's planned well, now we won't have any errors either if the script is written properly. And anytime we need to make changes, we can do it in one big script, which is incredible. So DevOps and automation can reduce errors and increase speed and scalability. So it's a great thing. And Google Clouds, like all clouds, have many DevOps tools. And we'll talk about some of the tools like Code Build and Cloud Run and other things like Deployment Manager. And they are there to help organizations build these continuous improvement, continuous delivery pipelines. So that's typically what we're talking about. So if we talk about automation in DevOps, and we really look in this DevOps cycle of what's really going on, it all begins with planning. Like anything, we should plan it before we do it. But then it's planned, and then it's coded, and then the code is built, and then it's tested, and then it's released, and it's deployed, and it's operated, monitored. And then again, there's a new planning to constantly enhance that code. So, this can do so much for us from a perspective of speed. Now, many of these building and testing things can almost be done in an automated manner as well. So if we start thinking about that, a lot of the work can be done or in an automated manner, or at least it can be checked in an automated manner and then checked by a human too if we want. But really, it's this constant cycle of design it, test it, use it, deploy it, monitor and operate, and then improve. So we're always trying to get better here. So one of the key concepts in DevOps is infrastructure as code. Infrastructure as code is writing a script that allows an organization to find what their technology will be like, provision that technology, and for the most part, manage it all in a single script. And this approach means less human error. Infrastructure scales and scales quickly. It's easy to scale. So the Google Cloud has something called Cloud Deployment Manager, and that's a native infrastructure as code tool that uses configuration files to automate the creation and management of things like virtual machines, networks, and storage. Now, understand that Cloud Deployment Manager is a Google proprietary tool. Now, given that most organizations are multi-cloud, would you use AWS CloudFormation? Would you use Cloud Deployment Module or Manager, or would you use something like Terraform? Well, that's up for your organization to determine which tools they use. But understand Google has a infrastructure as code tool called Cloud Deployment Manager. And it's very similar to AWS's CloudFormation. I think Azure calls theirs Bicep. But teams typically will use a third-party tool like Terraform.
No, we also want to talk about this continuous integration and continuous delivery. When I showed you that chart where we plan it, code it, build it, test it, release it, deploy it, operate it, monitor it, and then look for what we can tune and then fix it, we're constantly getting better. And if you really think about it, it's just a quality improvement program. We constantly get new things, but there's new changes in the business which demand new things, and we speed it up. And that's what the CI/CD is. Continuous integration is going to ensure that code changes from multiple developers are going to be automatically tested and then merged into a shared repository. And by doing so, we can start looking and identify issues earlier. Now, continuous delivery is more about extending the automation for automating the deployment of tested code into production environments. So much of this is automated to technology, significantly decreasing the burden of the number of employees an organization has to focus on this, enabling those people to work in much higher value environments. Now, we have this concept of serverless DevOps, and it's an approach that enables developers to really focus on application logic and not thinking about the infrastructure. And Google has Cloud Run, for example, and Cloud Functions that are serverless, where you just upload your code, for example, and they run, and they scale the capacity when you need it. And this does simplify DevOps things. If you relinquish control to everything, and you ever use everything in an automated manner, it will simplify your life, and it will increase the speed that you can do things. It will. Now, if you offload it all and use a provider's proprietary tools, it'll automate things. It's going to be real hard to use other clouds, and it's going to be real hard to leave. And if you need control over your performance or control over your security, and you need control, serverless becomes more challenging. So we have to think about what's right for the customer. And in many cases, serverless DevOps is great, especially because we can basically use serverless tools to host it, so we don't have to manage servers where our DevOps tools might even be. So I'll talk a little bit more about the Cloud Deployment Manager. It's Google's infrastructure as code script. So you typically define a YAML template, and you create that YAML configuration file, and the teams can look at that, and that's the language that would typically be done to actually deploy things. The Deployment Manager really simplifies scaling and disaster recovery, because think about it. You could write an infrastructure as code script, assuming you have good backups of your data, to launch all your assets in other cloud in less than 45 minutes from the time and potentially much less. So you can think about that for disaster recovery. Have a script writing in another cloud, keep all your data in another cloud, keep images of your virtual machines in another cloud, and launch it all with an infrastructure as code script in an emergency. Incredibly beneficial and a very cheap way to do disaster recovery. So now let's talk about some Google tools or Google proprietary tools for DevOps. We have Cloud Build, which is Google Cloud's fully managed CI/CD platform that's going to automate building the application, testing the code, and even deploying the applications. And it's going to support a wide range of workloads, including containerized applications or serverless functions. Now, where are these containers typically speaking? We typically have an artifact registry that we can use to store and manage Docker images or build artifacts, if you will. And we've got this kind of seamless integration with source control platforms such as GitHub. And that way we can streamline all these workflows where these tools are typically located. Code Build will dramatically help teams accelerate the delivery and ensure high-quality software releases. Of course it does. All these DevOps tools do. And why? They're automatically building, they're testing, and they're deploying applications without human intervention. So please understand this does enhance efficiency. Let's talk a little bit about the artifact registry. And the artifact registry is Google's repository service for storing and managing container images. Think libraries and build artifacts. And an artifact could either be a piece of architectural documentation as an architect. Software artifact could be a piece of code, or if you will. So, that's all we're talking about with regards to artifacts. And artifact registry will integrate into other Google tools like Cloud Build and Google Kubernetes Engine. And the point here, what they're trying to say is all these tools are automated. And yes, they are, which brings us to the challenge of the single cloud versus the multi-cloud. In most organizations, it's multi-cloud, which means we have to use more standardized tools. that work on all clouds and more standardized applications. And with that, we've got greater availability if we want to make it that way, because we're no longer at risk for a single cloud going down. If we wanted to do best of breed, where we say Google's best at this and AWS is best at that and Microsoft's best at that, and we share our things, again, we have that option. But we start losing all these native integrations, which make life a little easier. So multi-cloud is totally feasible, makes sense in most cases, or in many cases, but not all cases. But understand it adds a lot of complexity to remove some of these proprietary tool options. Let's talk about Cloud Run. Cloud Run is going to enable teams to deploy containerized applications in a serverless environment. It's going to simple DevOps workflows by managing the underlying infrastructure, scaling automatically based upon demand, and then handling updates. And that's what people like about these types of environments. All that stuff is already done for you. And Cloud Run is going to be great for microservices, APIs, or event-driven workloads. So again, it's enabling developers to focus on the code, and it's enabling the infrastructure teams to be smaller in these organizations. So if we go back to it one more time to make sure everybody got it, Cloud Run is to enable teams to deploy containerized applications in a serverless environment. So when we think about best practices for automation, we want to use templates and we want to monitor the configuration. By using a template that we know to be good, what we're dealing with is something that we can work off of, and then we can create modular configurations for various components. And that way we can come up with very consistent scripts. And Google has the GCP Deployment Manager will allow teams to create reusable YAML templates. And that means we can use something that can be reused in multiple places. Now, if we think about other tools like Terraform, they enable modular configurations that can be scaled or updated independently. So, that can also reduce the risk of errors during deployment. So we've got lots of tools we can use here, but use something that's templated based on what is your best baseline security, whatever, or what is your baseline, whatever. And then from there, after you can always tune that template. Most organizations would benefit from a very robust CI/CD pipeline. And why wouldn't it? Why wouldn't it make sense to increase the frequency that we develop our applications that support our business? This is a great thing. So most organizations will do this. Now, depending upon which tools they use, that's up to them. But Google has this kind of code build, which really makes it a little easier. It supports integration with source control systems, build tools, and container registries. So it makes it a little easier to create a robust CI/CD pipeline with some of these tools. Now, realistically, we're going to not want to take code and actually just shove it in the production environment for the whole world to see. We want to be able to test it. So typically what we do is we create what's called staging environments. And I can show you what that looks like. So an organization may have three kinds of environments. They may have the production environment. Now, this is the stuff that's live and supporting their business right now. And this stuff can't be messed with unless we're sure that it's going to work. Now, we might also have a development environment. And in this environment, this is where everything's created. But we want to keep these things that were created far away from this production environment in case there's something that goes wrong. We create some haywire code in here. So typically there's some filtering or something or micro-segmentation between the development environment and the production environment. Then we typically have a testing environment. And here's where it gets tested. And it gets all kinds of tested here. And this is where we know that it's good. Any bugs that we find in the testing environment go back to the developers. The developers fix it, and that's in the testing environment. Now, then we might put it into a staging environment where everything is set up the way we want it to be. And we So it's built here, and organizations have different philosophies, and they may not have a whole lot of these. The developers create it, then it's tested, then it's staged, and then it's pushed into production. So this is a very common way organizations actually implement new software. So that's what we're talking about, how to optimize this. We test it, we and automate some of the testing, we stage it, and then it's pushed into production, in some cases automatically. Now, if we think about DevOps, the whole point is to increase efficiency. If we think about cloud, yeah, it probably costs more, but it's convenient because we don't have to manage the underlying infrastructure. So in DevOps, and especially in this kind of training, the recommendation is to use serverless technology. So I'm going to tell you that's the recommendation from Google regarding the Google Professional Cloud Architect exam. And I'm going to tell you from an architect perspective, what I want you to do is I want you to analyze your client's needs, analyze the trade-offs of all things, and help with your client to make the best decision on the best technology. Only after understanding the client's needs, the way the employees work, the way the users access the systems, what the customer's needs, and everything else first, and then make a decision. But for the purposes of this exam, leverage serverless technologies in DevOps. And Google has Cloud Run and Cloud Functions, and they enable developers to deploy lightweight, event-driven workloads quickly and efficiently. If you don't know what I mean by event-driven, I will show you. So let's say, for example, we have our object storage. Object storage could be AWS 3, it could be Azure Blob, it could be Google Cloud Storage. So I'm just going to call it object storage. Now, a lot of times our object storage is kind of sort of connected to the internet. And because of this, if the user sets the wrong permissions on something, what can happen is this can be accessed from the internet, which we never want to happen. So what we can do is if a user sets something on the wrong permissions, we can have some kind of function as a service that's going to get activated and say, whoa, this is something wrong. Immediately take this thing and fix the permission so it's no longer usable on the internet. And that's an event. If this thing happens, some other thing happens. In this case, it actually immediately fixed a security violation. But event-driven is if we have something happen, and it could be a log notification and alert, go do something. So that's an event-driven architecture. Now, the key with event-driven architectures is we're not paying for servers to operate all the time, generally speaking. These can be automated to a function as a service, and we only pay for it when it happens. Now, that's great if it doesn't happen that often, but if it happens all day, every day, it's probably cheaper to run a server. So we always have to think about what's right for the actual client. Now, if we discuss the DevOps philosophy, it deals with the challenges in traditional software development, where there's typically a very rigid structure. How the software is done, how the QA is done, how the operations are done. And if you think about a factory where these people do this job and these people do this job and these people do this job and these people do this job, the people aren't really communicating with each other. And by breaking those silos down and getting the developers and the testing people and the operations people and putting them all together, they can work together, they can share information, and that information sharing enables quicker fixes, quicker introducing in production. So what it calls is, gives you is high velocity delivery. And it does. Now imagine this situation. Your organization and a competing organization are fighting for the next GPU, the next big new drug, I don't care, that's going to cure cancer, the biggest anything. And let's say it's dependent upon technology. Now, if we've got good DevOps philosophy, we have the opportunity to get it up running much faster, typically speaking by using infrastructure as code and using some of these serverless options than we would by building ourselves over time. So that's the key point is we get first mover advantage, we get increased velocity. And, if we think of a private cloud like Nutanix or OpenStack often being cheaper than the public cloud, which is why most organizations are hybrid multi-cloud. They put their high-performance workloads in their data center where it's cheapest, and they leverage the cloud for what it's good at. But if we think about the time where that new drug, getting it out faster than the competition means being the number one, for example, and that can lead to a big increase in revenue, I hope you understand how getting the technology out there faster, even if it costs more in the cloud, might be a strategic advantage. So that's the kind of agility we're talking about cloud computing, the ability to take something that may have taken 6 months before and do it in seconds or minutes. So that's what we're talking about in cloud computing. That's the benefit of cloud computing, that velocity of poof, get everything out there. And DevOps does support that. Now, DevOps is really a philosophy. It's not really a specific job title. So when you hear the term DevOps engineer, it's really something different than usually often what they're looking for. We're talking about this whole DevOps, and it's a philosophy, and it does include skills when we talk about a DevOps engineer, from development, from operations, often from cloud engineering, and they're kind of put all together in one person. So that's why DevOps is a philosophy, and DevOps engineering may be doing some DevOps, but they may be doing other things as well. I hope that makes sense. The key here is to break down those silos so the divisions are now working together. So we also want to do what we call a shift to the left, and that means shifting tasks early into the software development lifecycle as opposed to later. So shifting left, start thinking about security from the time it's even created, as opposed to checking for security holes after the fact. Shift left involves, starting to test, run code checks as you're coding it before you're even ready to test it. So that's what they're talking about. And the key here is it's going to be an end-to-end workflow focus, and DevOps is going to optimize the entire deployment workflow rather than people doing it individually. And that's what DevOps tends to do, is that one DevOps engineer replaces a lot of those admins that used to manually configure things. So let's talk about some key pillars of DevOps success. We want to reduce the silos between parts of the organization. Why do enterprise architects and cloud architects exist? So we can go to the organization, speak to their business executives, speak to their key stakeholders, speak to key figures in the organization, find out what that organization needs, and help come up with a strategy. And we can't do that if there's a disconnect. And that's why most technology projects fail, because there's a disconnect between what the people need, the organization needs, and what the engineers start building. And that's why architects exist. Now, DevOps exists for the same reasons. So while architects are focused on the entire strategy at optimizing business performance, the DevOps engineers are focusing on improving the speed and velocity of the technology by breaking down silos between testing and QA. So as you can start seeing, is trying to get to a bigger place, to not have separate people that are all doing separate things at the same time where nobody knows what anybody is doing. That's the whole point of DevOps. It's also the whole point of architecture, even though they're completely different careers. So some good things to think about. Understand that failure will happen. And failure is a learning opportunity. And that doesn't mean we work very carefully not to make mistakes, but it means failures will occur. And if there is a failure, make sure you learn from it. We want to typically implement gradual change. So we want to adopt a continuous delivery model with small incremental changes. Now, that's often better than one big dynamic change. If you're going to go in there and make a massive change in code, and it's going to change the experience, an architect like me is going to have to come in, and we're going to have to schedule training of people. We're going to have to get stakeholders buy-in to make sure the employee is adopted. We're going to have to come up with people that are going to be on site and answer people's questions. We're going to have to find champions in there to help support their rollout. So with a big change. And if it's a gradual change and it's just fixing a few things here and there, people tend not to notice it, and it's not a big shock to the system. So the key here is, with DevOps, we want to leverage tooling and automation. Anytime we can take a repetitive task and automate it, assuming we automated it correctly, we reduce the chance for errors and we increase the speed. We want to use tools to help automate the testing, automate the operations process to make sure we do it consistently and efficiently and inexpensively every single time. So let me talk a little more about that CI/CD concept. The key here is to create an environment where we're constantly getting better, as I showed you. And it's going to bridge the development team which are the people writing the code, and the operations team, which are the people that have to manage the systems. Because the people that manage the systems often know different things than the people developing the systems actually do. And we need to get them both working together. So let's talk about things about how that can be done. So it's going to integrate with code deployment tools. So that'll reduce the development time, for example, by operations, seamless transitions, and getting constant feedback along the way from other parts of the team. So with regarding best practices for delivering code, the key here is the CI/CD aims to deliver code more quickly with fewer defects and higher business value. So what are the steps to build a CI/CD pipeline? Well, they really begin with planning the development cycle, where we define the overall strategy and objectives for the development team. And at this point, the code needs to be written and it needs to be managed. So we need to develop and maintain code bases, ensure the consistency and quality of the code. Now, at that point, we have to orchestrate the build process. So what we really want to do is automate the codes being compiled and packaging of the code to streamline the deployment workflow. And then after that, we have to test it. We have to test and make sure the build actually works. Now, once we know the build works because we've tested, now we need to start preparing for deployment, which is where we ensure that all the code is ready for release and handling all staging and approvals from key stakeholders. Now, at this point, then the DevOps engineers will have automated the deployment of the code into the production environment. And then we will operate and manage the application as an organization. I mean, not the architect, but the operations people will be managing that application, monitoring it, and always looking for ways to improve its performance. So if we build the continuous integration platform, the key here is to centralize our development tools, generally speaking, and we'll use tools like Jira or Asana for planning the development cycles, any kind of project planning tool. And then we may manage the source code in an environment like Git, and store code repositories in an environment like GitHub or GitLab or cloud source repositories. And then we want to orchestrate the build process. We want to be able to compile binaries and package codes using tools like, say, Maven. And we want to store completed binaries in repositories. For example, Artifactory is one, but there's many others we can think about. Now, we want to integrate testing into that CI/CD pipeline. So let's talk about unit tests. Now, unit tests are where individual units of code are tested in isolation, often using like a mocked-up version of an external environment where it's connecting to external dependencies, things like databases. And this is primarily going to be run by a developer during the development lifecycle, especially before they're going to commit their code. Now, at that point, there's going to be some integration tests, which is going to test how various components of the application or its modules work in the complete environment. So this is typically run before a major commit. These tests obviously are shared responsibilities across teams because we're actually doing some testing and integration tests. This is going to work in the real environment. And in a well-functioning DevOps team, developers we're going to be running integration tests to ensure that changes don't break any other components they have. Now, we might also be doing what's called end-to-end tests, which is going to test the entire application from start to finish. And that's going to ensure the system's functionality, integration, and even the data's integrity. Now, of course, we may do some additional testing. We may be doing some static code analysis to scan for security vulnerabilities, resource leaks, or other issues that we may find during or after testing. Now, let's talk about the repository push. Now, once the tests are successful and we know the build is good, the build is going to be pushed into a repository and prepared for deployment by an automation server. So I kind of hope that makes sense. Now, if we think about going back into the continuous deployment, since we already talked about continuous integration, the purpose here is to make sure that is designed to push all changes or features into the process, whether that be configuration updates, whether it be bug fixes, where it's constant improvement and constantly deploying it. So the key here with the continuous deployment is it has to be validated before it's deployed. So by this stage, the pipeline is going to have everything validated. and build it into it, and it's going to be built into a deployable state. Now, at this point, there may be some mistakes that have slipped through, and the DevOps model tries to minimize the defects that it finds. So let's talk about over-testing in DevOps. So code is consistently going to be tested here in the background at every stage, and developers are going to be responsible for testing and validating their code thoroughly and make sure that it's properly tested. The point here is that CI/CD frameworks can be designed to work in an over-test code where we've just got so many tests along the way. And that way we're going to reduce the defects that we actually find. Running continuous variations this way and validations and testing is going to ensure higher code quality. Now, with this continual deployment, there are some developer responsibilities. Developers are going to be responsible for testing their own code rather than pushing the responsibility to another team like a QA team. Now, this is going to improve efficiency, and it's going to align testing and development. So with regards to best practices, as much of the end-to-end testing and validation that can be done as possible is really what we're trying to do to maintain high-velocity, constant automated tests, which means we get better code, which we can put in production much faster. So try to automate as much of that as possible. Now, of course, with regards to continuous deployment, infrastructure as code really shines here because it provides a very easy way to interact with certain things and make changes. And think about tools like Terraform, Ansible, or the Google Deployment Manager. And they basically treat the infrastructure as if it's software. So we use software to create our virtual data center environments. And it can be managed with very clean code, good source repositories, change management, and we can prevent against misconfigurations and also deploy things more rapidly. So infrastructure as code is going to speed things up. Of course it is. One little script can make things that would have happened in months or even a year done in a matter of minutes. So it's going to help a lot, especially by deploying pre-written templates. Now, it's great for configuration management because if we think about what would happen, if we had 100 different people setting up a bunch of different things, there will be variations between their configurations. It's called configuration drift. But if we've got an automated template that's done by one person, that's checked by multiple people, and all it's going to do is deploy the exact things configured the exact same way, repetitively again and again. Now we've reduced our configuration drift, which means we're probably more secure because we'll make sure that any security vulnerabilities are going to be or weaknesses, and we'll have access lists controlled, and whatever we need is going to be done in this configuration. So again, automated provisioning, lots of speed. We're not manually provisioning things, which means we're basically going to not have human error, unless we have the human error in the script. So we have to be very careful who writes that infrastructure as code script. So it's all going to automatically attach databases, services, virtual machines. It can do whatever it needs to directly through this template. So it basically makes the cloud on demand. Want something? Do it. And I have friends that needed 10,000 servers to actually test firewall encryption. And what they would do is they'd write a script on the Google Cloud. They would spin up 10,000 servers or the AWS Cloud or the Azure Cloud, depending upon which one they needed. And then they would spin up the script, use the traffic and test whatever they needed to. When they were done, they would just close that script and it was all gone. So it makes the cloud truly on demand. So make sure with infrastructure as code that things are templated. The templates are well governed. They're stored in repositories that the wrong person can't get access to and make changes to. They're scanned to make sure there's no deviations to the thing. So we need to make sure these things are perfect. With regards to source control and monitoring, we need to make sure that any repositories we have really strong, fine-grained, tight access controls to make sure only the people that need access to it are getting access to it. We also want to manage service accounts. So we want to manage service accounts securely and apply the principle of least privilege to make sure that we don't expose any kind of credentials. And we always want to think about risk management. Consider locking down infrastructure as code platforms, for example, or use GCP managed services like the deployment manager. Any systems that are running infrastructure as code that we manage, we need to make sure they're patched, updated, and they're secure. Because if we think about security risks with infrastructure as code, imagine somebody tampers with it. So we've got the repository and the template risk. Unauthorized modifications to an infrastructure as code template by a hacker, for example, it could mean we deploy something bad with open doors, for example, and it can jeopardize your infrastructure. So you have to be able to detect and prevent any changes. So imagine the service account would be compromised. That could be another problem, because we might have one system that's connected to another system with a service account that has fairly high privileges. Again, that could be there. So we have to be very careful to make sure nobody can find out any information about these things. So we want to minimize any kind of access through multiple service accounts. And when we use service accounts, we want to use the principle of least privilege. So when it comes to DevOps strategies, realize there's not going to be a single approach. There's going to be multiple deployment strategies, and they're going to be based upon the availability, performance requirements that we typically have, the complexity of our applications, as well as the experience of the people doing the deployment. Other things that will influence our strategy choices, for example, availability. And high availability applications that need different downtime might need slightly different deployments, or very different deployments. Performance requirements may also change things, for example. For example, if you need to guarantee performance, you need to guarantee the systems, you may need to own these systems. The complexity of an organization's application can really determine how much they will benefit from DevOps or not. And the deployment experience an organization has will really help a lot. Typically speaking, less mature deployment pipelines will typically require more conservative strategies to avoid failures. We are back here to see if anybody has any questions. We've got just a couple more lectures to go today, about a 20-minute video and then a 37-minute video or so after this. So did anybody have any questions? Apologies, I was checking on something behind the scenes real quick while this was going on. If you've got any questions, just let me know. If not, here's the key. We'll keep going and let you know. So I'll wait to see if there's any questions. In the meantime, if you give me a hashtag Google Professional Cloud Architect so I know you're awake, alert, and oriented. Maybe if you're having a good time, you give the video a like or subscribe or something like that. And as a reminder, we've got a completely free guide to go along with this. If you just found us and you just joined us, you can sign up for that free guide, as well as go back and see the previous 7 days. My team will drop the link of the free guide and the previous 7 days. You know what, Chris? I know you're back there. Maybe drop a link on how to become a cloud architect. There's a document I wrote in the chat box that I think may help a lot of people. A lot of people want to become a cloud architect. They confuse it a lot with cloud engineering. And even though we've got a free webinar tomorrow where I hope to meet everybody, maybe drop the link to that free guide to maybe give somebody a chance to read certain things. And then I get to meet people on the webinar tomorrow and talk to them. And I'd love to do that. And of course, we have an architect webinar tomorrow on how to become an architect. We'll go over the role, talk about what we do, why we do what we do, how to get hired, all of it. And it's all free, live on Zoom, and then we'll answer questions. So there's that. Okay, so I see from Team Escalate, you have some clear expectations, and that's why you don't have questions. Love hearing that. I see some people are listening with the hashtag Google Professional Cloud Architect from Team Escalade, Jacques, Dimitar, Sergio, and Adrian. That's wonderful. So, Chris, let's keep going. Now we're going to discuss some application deployment methodologies, and this is a big component of the Google Professional Cloud Architect certification and exam. And I want to make sure you understand them. So what are they? They're strategies on how you would deploy your applications to reduce risk, for example. And that's typically the way we would deploy our applications. And I'm going to draw them out for you. First type of deployment strategy we have is something called a blue-green deployment. And the blue is the current environment. And the green, which we're going to draw here, let's put it over here. And the green is going to be the testing environment. or the new application, for example. New application / environment. And let me make sure that's green. I want to fill this green. Okay, so this is a blue-green deployment. We've got a Karen environment, which hosts our organization's website, which is blue. Now we have green, which is the new application we tested. So the way this would work would be over here. We would set DNS, for example, to send 90% of the traffic to a Karen environment. And we'll see why we do this 90. Oops. % to the old environment that we know is good. And then maybe what we do is we have DNS send 10% to the new site. And by doing so, now we've got the Karen environment, which is we know is good, handling 90% of our traffic and 90% of our service. And then we stick 10% on the new environment. Now, let's say the new environment's working great and everybody uses it. No big deal. We get rid of this DNS where we send 90% to it. We change 100% to the new application or the new website, and everything goes over to the new application. This could be done via DNS. There's lots of ways we could do this, but for website, we would typically use DNS. Now, that is a blue-green deployment. And if you think about it, it's going to be a great way to test things. Blue, again, is your live Karen environment. Green is the duplicate environment with the new application. It gives us a chance to do this. So what are the benefits? Minimal downtime. There should be almost none, because what we're really doing is we're sending a big percentage to our old environment, which we know is safe, a small percentage. And when we know it's good, we shift to the brand new site. So it reduces risks and it tests things in a production-like environment. So because it is a production-like environment. Now let's talk about another kind of deployment model called a canary deployment. And the canary deployment is a little bit different. It's not that much different. So let's say we've got a company. And the company has its primary applications over here. Primary infrastructure application, whatever you want to call it, just call it primary application. There'll be more than one, but now if we look in this environment, we've got the customer, they've got the primary application. Now in the canary, and I'm going to make it yellow so you can see it's canary because there's a color yellow called canary. And here's what we do. We have our friendly users here. And in a canary deployment, we change the color of that text so you can see it. So let's maybe make it red. Okay, so we've got our friendly users. So what we do is we keep all the business traffic on the primary application, and then we give it to some people that we like. Here, test this stuff for us, what you actually find. So the tests come back over here from people we trust, the friendlies, and then they shift all the traffic to the primary application. So why might we do this? Well, it reduces the risk, right? Because only a small percentage of users are going to be using the new thing. It gives us very good real-world testing because we're going to give users a chance to actually try things. And then you're ultimately going to be able to roll it out. So this is a fairly a good way to do things. Now, it's not going to be easy to set up the routing if we're using an internet-facing application. You see over here, with the blue-green deployment, I use DNS to load share. Now, over here, we might have to do some other things because we're not going to have DNS to be our option there. Okay, so we covered a blue-green deployment, and we'd covered a canary deployment. Now, what we're trying to talk about here with DevOps is often rolling deployments, and that basically means we're just gradually rolling out new instances of the applications that we have, taking a version that we have and replacing it one at a time. So for 10.1.1.1, maybe it goes 10.1.1.2 that we push it out. It's just something slightly new, small changes. Now, another thing we may want to do is something called A/B testing. And A/B testing is widely used in marketing and other environments. And what we're going to do here with A/B testing is we're going to release two different versions of the application. an A version and a B version, and we're going to compare performance. So this is very common in a lot of environments. You've got the A version. You've got the B version. Oops. So we've got these two different versions. We try both and we send it out to people. And when we send it out to people, I mean, realistically speaking, they're either, what if 80% of them say, I prefer B? B performs better. The company will just switch it over here. So we've had a lot of good options. So if we think about the blue-green, let's say we had, let's go back to this because I want you to think about the fallback mechanism here because it's pretty incredible. Let's say we started out sending 90% to the current environment. And we started out by sending 10% to the future environment. Now, all of a sudden, we tell DNS, send everything back to the new application, send everything to the new application environment. And all of a sudden, we have a problem. No big deal. We just tell DNS to go back to the original environment. So that's your backup plan. Or what happens if 90% of your traffic was going to the current environment, well, and 10% of the traffic was going to the future environment doesn't work well, just shift it all back to the current environment. So that was working beforehand. So that's the rollback and the safety of the blue-green deployment. It makes it very easier. So you may on the exam, you're going to get scenario-based applications that's going to understand what these deployment models are. So, if we think about the blue-green and we think about these strengths, it makes it very easy to roll back. But it's going to temporarily double the organization's infrastructure costs because they're going to have an old environment and they're going to have a new environment. And depending how long they want to keep what was the current environment, which will become the new environment, alive, means how long they'll be paying for it. At least keep thinking about that. Now, if we use that rolling deployment, we have a single production environment. We're just going from one thing to a slightly new version of another thing. And in this case, application updates are going to be deployed in a very staged manner across servers. Some may run the new one. Some may continue to run the old version. It gives us some form of real-life testing. And we can do traffic testing and load testing on the new version before deploying it on all servers. Now, with the rolling deployment, which is where we just keep making incremental changes, if an issue arises with the new version, we just go back to the servers that were running the old version. So we can think about that. But I want you to think about this rolling environment. The complexity is going to increase a lot with major changes. And if there's major changes in a rolling deployment, the support team must learn very well before the application is rolled out how they're going to troubleshoot this environment on both old and new versions. So it can get complex. So rolling deployment is great because it minimizes downtime and provides the opportunity to test things gradually to validate new things. But if you think about it, it's a big change, so it's typically a bigger risk. Now, with that canary deployment, where we only send it to a subset of users, now we're targeting users, not the servers themselves. So if we think about that, we are going to have a friendly subset that we run on the new system, which brings us back into the same kind of cost structure we have with the blue-green, where we have to maintain two separate environments, which means we get greater infrastructure costs. But we get to test it in a production environment with people they trust, which reduces the risk. So I hope you're starting to see each one of these options has various trade-offs, and we have to pick the right one after evaluating all trade-offs. Now, let's think about the canary deployment. Now, again, this is going to be a lot of infrastructure. It enables that gradual rollout. It enables very good risk mitigation. It seriously reduces risk because if an issue arises with the new people we're testing the software on, just move them back to the original version and then we don't have to worry about it. So severely reduced risk, what we're talking about here. Now, when we talk about that A/B deployment, which we talked about, now let's think about what's going on here. This is basically like running a focus group with your users. Do you prefer this or do you prefer this? So you're splitting your users. Basically, half are going on one and half are going on the other. Now, this is going to give you a lot of insight. It'll give you information on user behavior and usage patterns, and then you can figure out which one of these is going to get you better business. Imagine one e-commerce website has people stay on the site 5 minutes longer, and they're more likely to spend money, and they're more likely to spend on average 6% than the other one. Well, shift all traffic to the one that's doing the most things. So A/B testing gives us a lot of insight. It really helps us find other things that are working. Now, A/B testing gives us what we call data-driven decision-making. Users like this one more than this one, so use this, which is always good. A/B testing is what you call a controlled experiment. Experiment test group A, experiment test group B. See what your users prefer. And that way you don't have to commit to any single version of anything until you know where you should really put your money. And this gives you iterative improvements because you've got a way to test. And you want to try a new version of your site, keep what you have, send percentage of users somewhere else. If they don't like it, they're not buying as much, send them back to the original. So it's not exactly what you would consider a full deployment here. It's going to be an iterative process to get better and get better and get better. But, success is partially knowing what your customers want and giving your customers what they actually want. Now, when it comes to deploying things, let's talk about some deployment tools. Google has Google Managed Tools, and they offer a variety of managed tools that are operationally cost-effective and can reduce administrative overhead. Most of the DevOps tools we're talking about are serverless, and that makes them fairly easy to maintain than if we had to maintain our own servers. But if we need control, we might want to maintain our own thing. Now, many of these tools are serverless, so think about no need for virtual machines, no need for you to worry about the storage environment, no need to worry about updating your machines, but at the expense is you lose control. So understand that Google has these tools, just like AWS has their proprietary tools, and Microsoft has their tools. So maybe pick something that works on all clouds or pick on which one's best for your client, ultimately in your decisions. So Google has some deployment tools, and there's some pros of these. There's some benefits. They're native. They're integrated into all the Google stuff. Auto scaling, high availability, at least as good as you're going to get out of a single cloud. Very little operational burden and to think about. Now, if we don't use a cloud native tool, we have limited customization. And that may be true, but we may need to use a tool that works on all three of our clouds. If we don't use a Google tool, we're typically going to be in an environment where we don't get vendor lock-in. Or we may get locked into that particular tool, but that might be worth it to yield with one tool that works on all of our clouds. And the feature set of a non-Google tool may have less features on Google. Of course, it may have more features that you need for basically your overall environment. So I'll talk a little bit more about some of these tools. We've got Cloud Build, which is a continuous integration tool for automating the building, testing, and deployment of applications. It's serverless and it supports multiple environments. And then we have Code Deploy, which is a fully managed continuous delivery to automate release pipelines and deploy applications. I want to say it again. Cloud Build is continuous integration into the systems, and Cloud Deploy is continuous delivery. Now, let's talk about Cloud Run. That's going to be a serverless platform designed to run containerized applications without needing to manage the infrastructure. And the artifact registry is going to be a centralized place to store, manage, and secure your artifacts from various repositories such as Docker or maybe a Maven type artifact. Now, if we talk a little bit about the Google Cloud Deployment Manager, the point here is, again, it is a Google infrastructure as code. And I know we talked about it earlier, but if you notice what we're doing is we talk about it and then we get into deeper information about it. So the Google Cloud Deployment Module is really there to enable creation and management of infrastructure as code tools. That's what it is. It's a cloud proprietary infrastructure as code tool. Very similar to AWS CloudFormation. and fairly similar to Terraform, except for Terraform works on all clouds. Now, GCP Cloud Deployment Manager is Google's homegrown tool for managing their systems. It's not going to be the most popular, and the reason it's not going to be is most organizations are multi-cloud, so they're going to use tools like Terraform. And most organizations tend to prefer these multi-cloud tools, but at least you know what they are and why. Now, the Google Cloud Deployment Manager is single cloud. So it doesn't support multi-cloud environments. So like I said, the utility of these tools like AWS CloudFormation, Cloud Deployment Model, it typically not going to work in the average environment we're dealing with today, especially the enterprise environment. Now, it's YAML-based. So the way you would create a YAML file in Kubernetes, you add another markup language. YAML is typically used for Google Cloud Deployment Manager. It allows for any kind of, I think they call them Gina 2 extensions and custom Python integration. So it's fairly flexible in the way it orchestrates things. But again, it's limited to a single cloud. So this is going to be a great tool for organizations that are basically heavily invested in Google Cloud and they don't have any immediate need for multi-cloud services. I don't know any clients like that because typically I work with global enterprise clients and they can't leave all their eggs in one basket. But if you have a client that only uses one cloud, this could be a beautiful solution. Now, Cloud Build, again, is serverless, and it's designed to build and test and deploy code. It provides complete control over the CI/CD workflow, and it allows for the building of software using any programming language. It can deploy across environments like virtual machine, Kubernetes in containers, and other managed services, and it can be integrated into third parties. So you could connect it to, say, Apache Maven, or it can be set up to use, say, Spinnaker or other tools in DevOps. Now, Cloud Build is cloud native, and the key there, remember, it is a serverless, so nothing for you to think about or manage. Cloud Build supports a wide range of tools, and it easily integrates with other cloud providers' things. Now, this is a little different because it's not in what we were talking about before. This is going to be recommended for organizations that are looking to modernize their CI/CD pipelines without a lot of extensive integration. Now, if we have containers, we need to store them somewhere and make sure they haven't changed. So that's what the container registry is going to be for in Google Cloud. It's going to be a private Docker repository that will enable us to store, manage, and secure Docker container images. It can help us with vulnerability analysis. It will provide vulnerability scanning to ensure the container images are secure and free of known vulnerabilities. And with regards to access control, we can manage that with the IAM to determine who can actually make a container image, access it, and anything else that we need to do. And the container registry has strong CI/CD integration. It's going to support any kind of CI/CD pipeline that we want to deal with for the most part, ensuring fully automated Docker pipelines. And it's fairly efficient, the container registry. It's going to speed up the deployment process by integrating, because it's integrating with your container environment and creating a place to keep them, store them, or whatever. So it makes things much more efficient. Oh, well, sorry about that. We had some audio difficulties. That looks like I was muted on one of the sides, my side, whichever side that is, but that's taken care of now. So wanted to check in and see how everybody's doing. Wanted to see if anybody had any questions along the way, anything they needed us to assist with, and say that we've got one more video. It's approximately 35 minutes. Wanted to let everybody know that we are going to finish on Thursday, so you're going to have a free Friday. Congratulations about that. We're almost there, so stick with us for about 35 more minutes. I didn't see any more questions come in, but if any do, just let us know. We've got one more video. We'll finish up for the day. So as a reminder to everyone, we're going to have a webinar tomorrow at 11 a.m. We'll go over the architect role, what we do, talk about how to become an architect, talk about what it takes to get hired when you lack experience, all of it. And of course, you can ask me live questions on Zoom, so please join us.
And as a reminder, if you just got here out of nowhere, YouTube sends people notifications all kinds of times that you can go back and you can watch the first 7 days of this. Chris from my team will drop the playlist so you can see the previous days in case you missed something. Or you want to go back and watch it again, which I highly recommend. Watch it 2 or 3 times, read the guidebook, and then go take that exam and go get your Google Professional Cloud Architect certification. So I don't see any questions pop in. Maybe give me a hashtag Google Professional Cloud Architect so I know you're awake, you're alert and oriented. And Chris, let's get back to that last content.
Now, we've been discussing DevOps, so let's discuss DevOps' close cousin, SRE, or Site Reliability Engineering. And while DevOps bridges the gap between development, testing, and operations, Site Reliability Engineering is an implementation of DevOps with an additional focus on reliability. So it combines more operational work with development work, and the goal here is improving performance and availability. So Site reliability engineers kind of split their time in between the following: operations-related work like handling issues and on-call situations and manual investigations, but also development and automation. So they're building features, potentially scaling infrastructure, they're potentially automating a process. Anything they're doing, their focus is really of availability and reliability. So SRE introduces the concept of something called an error budget, which allows for a tolerance of failures to a certain threshold. So what does that mean? We can now set a threshold that says we could need, say, 99.9% uptime, and there's an error budget of 0.1% downtime. So that's all it really is. So instead of just using the standard numbers of 99.999, for example, which is about 5 minutes and 15 seconds of downtime a year, they're calling it an error budget, which is what you're able to tolerate. And if the error budget isn't spent, meaning you didn't have enough outages, it signals to the person that maybe they took have too much reliability and too much resilience in the system, and potentially they could reduce that reliability. Although most businesses really are not looking to decrease their availability, but imagine an organization is spending $100 million a year to get to, and they have 5 nines availability, but maybe they could reduce it to say $50 million a year to get to 99.99% availability, which is what that business needs. So yes, it is about matching availability needs with expectations. So that's why they have this concept of an error budget and what it might mean. Now, if the error budget is spent, then at the same time, maybe they need to focus more on reliability. And they need to do other things to enhance resilience and availability in the system. But the goal is really just to align the organization's needs, again, with what the organization is actually doing, to maintain the correct level of availability and at the most appropriate budget. Now we're going to cover cloud operations, which is the next kind of section we'll talk about in preparation for the Google Professional Cloud Architect certification and exam. So we're going to talk about logging. And when we're talking about logging, we're talking about all the systems that generate logs and collecting them or doing something with them. Now, with regards to logging in the cloud, we have cloud logging, which is real-time log management. And cloud logging is going to be a Google fully managed tool for storing, searching, analyzing, monitoring, and even alerting you on log data. So all these providers have some form of a logging. For example, AWS has CloudWatch logs, which you get to see, and other types of logs. So all providers will give you this. Now, what we want to do with these logs is up to us. We can ingest the logs somehow, and we can put it in a database. We can put the log somewhere. So cloud logging is a real-time log management tool from the Google Cloud to deal with logs. And cloud logging natively integrates with cloud monitoring. So it's going to allow users to define alerts based upon whatever it is. So that means you're going to get performance metric things like the CPU is too high, for example, but you'll also get other system logs as well. And it uses a logging agent. Basically, they can run on any of your virtual machines that'll collect logs from those virtual machines and provide those logs. And it can give you a centralized, scalable logging environment. Now, with regards to cloud logging, the primary way to view it is with the logs viewer. And that is going to be a simple, very graphical interface that's going to enable you to store, view, and analyze cloud logs with cloud logging. And it allows users to build and save queries of certain types of things that they might use for the future. And this can be done via graphical user interface or, some type of a query builder language. Google Logs Explorer is the primary interface to view logs. And why am I saying this? Because Logs Viewer is the right thing to view it as the primary way. You might see that in the exam. What's the primary way to do it? View logs, and that's the log viewer. But you can also view logs if you have some type of an API integration. So you consider programmatic management of logs, and this enables users to read, write, query, and even control logs with the Cloud Logging API. Now, when it comes down to it, we're going to have some log entries, right? And log entries are going to be recorded events that are going to be captured from various Google Cloud sources, third-party applications, custom applications, and then what we're going to get is logs, which are going to be really a collection of log entries and all kinds of information. So if we didn't have a log entry, we wouldn't have a log. Now, at some point, we have to think about how these logs get to their destination, and that's going to be called routing and exporting. We're going to take our logs and we're going to export them somewhere. And then maybe, hopefully, we get some metrics out of our logs, and we can pull these metrics and get some factual science-based things in our logs that are going to help us do things. So if we think about how long we should keep our logs, well, it's really going to be dependent upon the industry and organization is in. So by default, our logs are going to be stored for a retention period of either 400 days or 30 days, depending upon the log type. So 400 days is a little over a year, so that's pretty good. 30 days is not long, but if it's not critical logs, you may not want to keep them anyway, unless you have to. Now, what if you need to retain the logs for a long time? Well, you can use what's called extended retention on the Google Cloud, and you can store them for up to 3,500 days. I think it's about 3,560 days, about 10 years. So you've got very good long-term storage. And many organizations will use cloud storage for long-term log retention. And typically speaking, they might want to use BigQuery for advanced log analysis. So you've got a data warehouse that can look at these big logs. And what kind of evidence and trends can you glean from them? Now, we also have this concept of log routing and automation. So what are we really talking about that? We're really talking about the need to somehow get the logs from its source to its destination. And that's really all we're really talking about. So let me whiteboard some of this out for you, because I think it'll help make it easier. So let's say we have some logs coming from somewhere. Let's say these are Google Cloud logs. And let's say we're using an API. So let's say we use the Cloud Logging API. And what we're first doing is we're pulling these logs via the API, and then we're going to need some kind of a way to get our logs to wherever we want them to go. So by this kind of thing, we're going to need some kind of log router, which is going to tell the logs where they need to be. And that way we know exactly where we're going. So I kind of hope that's going to make sense to you, that we need a logs router. And what can we do with the logs router? Well, we can send it wherever we want. So at this point, maybe we send information to, say, object storage. So maybe what Google calls their object storage cloud storage. Or maybe maybe we want to use a data warehouse to go query these logs. So we'll keep it Google specific since it's a Google certification. So let's say BigQuery. Now, we might still also have some logs going just to the logs area. But the ability to take these logs and send them either to long-term storage, be able to query these logs with a data warehouse and glean information out of these logs, and the ability to send the logs to the regular log places too, if you wanted to do it, is also good. Now, we can also send these logs to what's called SIEM systems, which are security event monitoring systems, and that's really where we're going to have some heavy-duty integrated security across our clouds. Okay, so that's why I wanted to discuss a little bit about what this logging and routing is. It can be done via, say, the Google Pub Sub, which we talked about earlier. And that way we can route it to a topic, and that way it can be fanned out to wherever it needs to be. You would typically want to fan these logs out to a security event monitoring system, like Splunk, for example, but there's many others in the world that can do that as well. The point is, we want to take all these logs, we want to glean information out of them, and if we're using some kind of AI SIEM system, we can potentially catch attacks in real time and then do something about them. And of course, there are other log analysis tools that DevOps teams or operations teams or whoever's going to be looking at these teams can actually, there's other tools they can use to parse through logs and such. And they don't have to just use Google's native cloud operations tools. So when we're dealing with log router, we were dealing with some cloud logging API, and these logs are automatically going to be passed through the cloud logging API. And that way they're going to get to the log router. And the log router, what is it really doing? It's determining which logs it's going to take in, which logs it's going to export, which log entries it's just going to get rid of. So let's talk about log syncs and exclusions. We have a default log sync, and each project has a default log sync that routes all logs into a default log bucket. Why they call it a sync, I have no idea. But all logs are going into a single default bucket. Now, we can set up what's called exclusions, and exclusions can be leveraged to filter out specific log types from being stored in cloud logging. And that way, if we don't want to catch some kind of logs, which we typically know are meaningless, but they're just kind of things that we're getting all the time, and we don't want to store them, we can save on logging cost if we know certain things we want to block. Now, when it comes into log ingestion and how we're going to do it, there's a couple of options. We can do custom logs. And the Cloud Logging API will support the ingestion of custom log data from, for the most part, any data source. And that gives us some scalable managed cloud logging in a managed environment. So think about things. If it's managed, there's less servers for you to be dealing with. For example, there's no patching of operating systems. So that's somewhat a managed service, which in this case might be a great thing. And cloud logging supports real-time log analysis, so you can look at it and try to glean information in real time. So if we talk a little more about cloud logging really receives, indexes, and stores logs from various sources. That's what logs do, and including Google Cloud Services. But anything that you put the Google Cloud Logging agent on, or even other cloud providers, you could input their logs under certain circumstances based upon the way you would set up the custom log sources. Logs can be captured for the most part at every layer of the resource hierarchy, the organization level, the folder level, even the project level, if you recall when we talked about that earlier. So we can, with cloud logging, we can export the logs. We can do a one-click export to BigQuery, which is what I showed you initially, how BigQuery we could then use to then take the data, and we could use to analyze the data, visualize the data, what have you. We can run like SQL-type queries on the data to learn more. So that's what we were talking about with the cloud logging. Now let's talk about log types. Now there's lots of logs we're going to get, but let's talk about the key logging sources we're going to get out of Google. Well, we are going to get logs that are generated from all kinds of Google Cloud sources. Things like compute engine, cloud storage, and much, much more. Now, these logs will give us insight into the operations, the system's health, the system's performance, for example, user activity. So that we're going to definitely get it from Google Cloud. Now, we're going to get things from the cloud logging agent. So if we put this logging agent on virtual machines, it's going to collect their system logs, application logs, and custom logs, and that can be sent. So we can be collecting more logs, and we want to know what's going on with all of our systems. We can get logs from other cloud providers if we were going to do that. We can create what's called custom log sources, and users can create custom log entries for certain applications or systems that don't have built-in Google Cloud Logging in some way, shape, or form, and that way we can still send the logs to a single place. And these kind of custom logs can be generated for the most part from any source. And that's going to really allow for a tailored log collection, what we want, what we need, and get it in a certain order. Now, we also have hierarchy-based logging. And logs are going to be captured based upon the resource hierarchy. So organizational level, the logs will cover all resources under an organization. If we get folder level logs, they're going to be logs specific to a folder grouping multiple projects or resources. And if we get project logs, those logs will be to specific projects, and they will capture project-specific activities and events. So we can determine what we need and what we're trying to collect. Now let's talk about admin activity audit logs. So admin audit logs are going to be part of Google Cloud Audit Logs. And here's the point here. For the most part, to track back administrative activities here and user activities within Google Cloud and its identity platform. So what kind of activities would it be logging? Well, any kind of time there would be, say, a log related to creating an account or deleting an account or any kind of user-related management actions, unauthentication. So basically, anytime somebody logged in, it can record that. Configuration modification. So anytime someone changed anything inside of, say, the cloud identity platform or the identity provider environment, so you'll get notifications here. Password management, you'll get notifications of password changes and resets. So it's giving you a lot of audit there. So let's talk about a little bit more about that. So when we get these cloud audit logs, it helps us with the last part of our IAM. Remember, IAM is authentication, determining who you are. Authorization, which is what are you allowed to do. And then accounting, which is what have you done, and really auditing that, being able to track that. So that's really what we're talking about. So the administrative audit logs help you answer the who, the where, the when, and who did something to the systems. They capture API calls of user administrative actions or configurations. So anytime somebody modifies something to a permissions in Google, you're going to get that. Now let's talk about the data access audit logs. That's slightly different, and that's going to capture API calls related to reading or writing data or resource configurations, so or metadata or user data. So anytime maybe you change metadata on something, you're going to get a data access log. Or you change a resource configuration, you're going to get a data access audit log. And by default, these logs are disabled. And these logs are not publicly shared resources. So for example, it can help you read or write data to a service. You can log that and get that log if you want. If somebody accesses metadata or data about data within a service, you can get a log for that if you want to. It was the data access audit logs if you turn that on. Now we also have system event audit logs, and the whole point here is to record log entries for administrative activities that will modify source configurations based upon Google system activity, not user-initiated actions. So, for example, logging of a transparent maintenance event or something that happened by a system, like Google wouldn't do it. So the next thing we want to talk about is VPC flow log. So if any of you have a networking background and you know Cisco NetFlow from 20-some years ago, which would give you information about the traffic flowing through your system, well, network logs, VPC flow logs, it's the same thing. It's capturing data like Cisco NetFlow started doing a few years ago. And it's giving us the data, there's a TCP or is it UDP, the source, the destination, address protocols, port numbers, that kind of thing. So that will give us a way to see certain traffic inside of our VPC, traffic to maybe other VPCs that we're peering with or VPNs that we've connected to, traffic in between servers, traffic to Google APIs. You can typically get a lot of information about your network traffic through when you start looking at networking logs and the VPC flow logs. Now, under networking logs, we're also going to have DNS logs, right? Because we use a lot of DNS often. So the DNS logs will record every time there's a DNS query received inside of a network. And this will include queries from virtual machines, for example, and inbound forwarding flows. Now, the key here is we're getting visibility into our DNS traffic, and we'll find that it can help us resolve any kind of issues that we might have related to DNS queries. Now, we may have some network address translation. We most likely will, translating our internal addresses to private addresses as they go out to the internet, update your operating system, and allow that return traffic back. So we will also get logs for NAT, and that will provide some really detailed information about the NAT connections and NAT errors we have. And this will give us a lot of information in troubleshooting any kind of network address translation, especially in environments where they don't have a lot of external IP addresses and they're using internal IP addresses to go out to the world. Now we're also going to get firewall logs as well. So if we've got a firewall up, we're going to capture, it's going to block traffic, and it'll allow some traffic based upon policy. So we can get some pretty good logs out of a firewall. Source, destination, IP address, protocols, port numbers, timestamps, much more. And we can monitor systems to see what's being allowed, what's not happening. How often are people trying to hack us? Well, what is the firewall denying? Now, we're also going to get more networking logs. And the point is we need insight into why stuff is not working. Because if the network isn't working, you're going to have absolutely nothing. So you'll get lots of information from your network. And of course, this kind of audit trail that we're collecting is going to help organizations track any kind of challenges, validate their infrastructure, stay compliant. So we always need an audit trail of what's been done and how it's been done. Now, if we think about these logs, it increases the knowledge an organization has because they can see precisely what's going on in their environment. And they may need that to troubleshoot. And when we're dealing with security or high security environments, we need to be able to see what's going on to be able to understand how to stop them and protect them better. So logging is going to be really important. Okay, let's discuss CloudTrace. And CloudTrace really functions as a distributed tracing service, and it's going to give you information about performance, specifically latency. And the whole point here is to collect latency data between your applications. And latency is how long it takes for things to go through. So let me maybe whiteboard that out for you if you're not used to networking. So let's say we have two devices over here, and they're talking to each other. Latency will be how long it takes to go from point A to point B. So generally speaking, the shorter the distance between these two, the longer the shorter the latency, because we're dealing with the speed of light plus some other things along the way, typically speaking, routers or switches to regenerate the signal. But depending upon what it could be, it could be 1 millisecond across a line. If we're going, saying from somebody in Palm Beach, Florida to Miami, it could be less than 1 millisecond or less. Or it could be going to the cloud provider, which could be 3 milliseconds just to get to them. And if we have two environments that are further away, it could be 8 milliseconds or 9 milliseconds or even 18 milliseconds or more. Now, when we start getting to this point, especially if there's variations of latency, like this one would be 10 milliseconds, the next one would be 30 milliseconds, then the next one's 20 milliseconds. That's called variations in latency, which is called jitter. That can wreak havoc on all kinds of applications that are usually not TCP-based, like real-time applications like video and voice. So we need to understand what's going on. Now, if there's a server in here that's busy and the processor can't handle a task, that will also increase latency. If it's out of DRAM, it'll slow it down, which will also increase latency. So latency could be coming from the network, or it could be coming from various components of the servers and where the applications are hosted themselves. And we need to understand that. And that's where CloudTrace is going to help us. So it's going to be collecting latency data from our applications, and it's going to track how requests propagate through. So we get components of where the latency actually is, which is incredibly helpful in tracking down application performance that's not what it needs to be. So here we've got to monitor latency across our virtual machines, our containers, our app engine environment. So it's very useful for finding the source of latency in our environments. It integrates natively with App Engine. So if you if you're using that kind of service, you'll be getting information, and you can use this as well. But this does require the CloudTrace software development kit or API for being able to get your latency data. Let's talk about Cloud Profiles. So Cloud Profiler is a continuous CPU and heap management tool. So what it's really doing is it's analyzing the performance of the CPU and DRAM and memory intensive functions. So it focuses on identifying code sections that are causing high CPU or high memory consumption. And by being able to do that, you might find an application has inefficient code in a certain thing that's making something need a lot more CPU. And maybe you can tune that. Maybe you can't, but it's giving you a lot of information about what's going on in your applications and how it's affecting your CPU. And maybe you need a bigger server, for example, based upon what you get. Maybe you don't. But it gives you a lot of information on latency, And while CloudTrace gives you latency, this is going to give you information about the server itself and where is the CPU going on, DRAM going, and where in the code is it causing it to happen. Now let's talk a little bit more about monitoring. We have cloud monitoring, and that is a fully managed solution. You can pretty much tell it's a Google product with the name cloud in front of it. And it's going to give you full stack visibility into the performance, uptime, and overall health of applications. It's going to help reduce the administrative burden of managing the infrastructure for the monitoring service itself because it's a fully managed service. If it wasn't, we'd have to maintain our own servers for our monitoring and our own applications. We might still have to do that if we need it. So don't think that this is always a one-size-fits-all solution, but it's a Google monitoring option. And it can collect a lot of information. It's going to gather metrics, events, metadata from our Google Cloud environments. And if we could potentially do it from non-Google Cloud environments either, based upon how we're collecting information. And we collect information either via an agent or an API or even a third-party partnership. And it gives us the ability to visualize something and dashboard something. So you can think about cloud monitoring as something that you're able to do to see what's going on. Gives us a good data analysis. We can figure out what kind of metrics they're pulling. And cloud monitoring features a fairly extensive set of tools. It's got integrated monitoring, for example, so it can collect various metrics. It can create a dashboard for you to look at it in a single screen, if you will. Give you some good uptime monitoring and learning. And all these tools, typically speaking, especially with Google, they integrate very well with third-party products because enterprise-wide, we probably need a third-party product and we want to be able to pull the information via APIs from our cloud provider. Now, we can do what's called white box monitoring and black box monitoring, and white box monitoring involves monitoring all aspects of a server. So typically with ethical hacking, you're either given all the information or you're given none, and that's what we're talking about here. We're talking about being able to collect all the information. So, and it'll make it very visible. White box give us a lot of information. And it enables us to create custom metrics using APIs or libraries. So, we've got an environment to really get a lot of information here. This allows the building of log-based metrics and data collected in cloud logging. Now, we can also do what's called black box monitoring, which monitors the application from an end user perspective. So it's not requiring a ton of knowledge about the inner workings of the application. So it's more using uptime checks. So white box testing gives us a lot of everything, assuming with insider knowledge. And black box testing tests it from the user perspective. How's the user feeling right now? Is it feeling good to the user? Is it working good for the user? So let's talk about where we would use cloud monitoring. Well, we want to check our applications. We want to make sure that they're doing well, that they're healthy, that the load is right, that the uptime is good. So we're really trying to figure out what's going on, health, performance. And we're trying to collect metrics. So we want to be able to gather data from various sources and something that's going to be digestible and understandable for an analysis. And we want to have some kind of alerts to notify teams, wait, if something's happened, if it exceeded a desired criteria, go do something about it. And that way we can enhance incident response. Now, cloud monitoring is also a managed service, and that means you don't have to manage the infrastructure you typically would to in order to create these types of environments. I'll talk briefly about Google Metrics Scope. And Google Metrics Scope is a feature inside of the Google Cloud that allows you to centralize and manage your metric data across multiple Google Cloud projects. Now, this is going to help you achieve a unified view of your infrastructure's performance and health by aggregating metrics from various projects under a single monitoring workspace. The key here is you've got some unified monitoring. It's going to streamline performance analysis because you're going to have all the relevant metrics in a single dashboard. So you're not going back and forth, say, between projects. It gives you very simplified alerting. So you've got a centralized view. You can set up any kind of alerting policy you want that spans potentially even multiple projects. So you can detect issues fairly easy that might affect the system. And because you're getting this kind of data with Cloud Metrics Scope, it may help your troubleshooting team find problems and fix them. So how it works, it aggregates logs. Basically, you create the project and designate the metrics and scope. and it'll aggregate the metric data from the associated monitored projects. This means you can create your dashboards, you can set your alerts, and analyze performance in a single place. Now let's talk about monitoring agent. So an agent is typically something you put on a system and then it sends information back to the server or the master server. Or the manager, depending upon the term that's actually used. So the point here of monitoring agent is to collect a lot of information. So you put it on a system. It's for the most part, it's a daemon that runs in the background, and it'll give you information about the virtual machine. Now, by default, the agent will collect metrics on disk usage, CPU performance, network activity, and various process metrics. But you can customize it. So you can customize it to monitor a third-party application beyond the system metrics. And again, this is optional, but it's recommended. Why wouldn't you put something on your systems that can monitor your environment, send it back to a central place, and get better information? So typically speaking, there's always some kind of endpoint protection we use. This would give us lots of information. Typically on an endpoint, we might also put like a host-based firewall, host-based IDS, IPS system, that kind of thing. Now, why would we be doing this? Because it gives us a lot richer data. We want a lot of information so we can make better decisions. We take all this data, we start sending all this data into SIEM systems, and these security event monitoring systems can find things that are happening that we don't want to happen. But what about if a virtual machine's too busy, it doesn't have the disk I/O performance it needs, or it's low on DRAM, or the CPU gets too high and it's not offering the right performance? We can get that kind of information by monitoring these things. Let's talk about another thing we would want, something called uptime checks. Now, we need to make sure our systems are up and available, right? We need to make sure they're working, because if they're not, business is going to be lost. If we have an e-commerce website and it's down, no revenue's coming in. If we have a hospital and the system's down, well, that's all kinds of problems. So we want to be able to check uptime, and sometimes we want to check uptime and be able to know what's going on when we're not paying attention to the system. So what uptime does is it sends a request to the application, and if it responds, we know that it's there, and that it's alive and it's available. So it's a lot like a health check, which we use in DNS and network load balancers. No, this is a little different. It might actually do more of an application level check, but same kind of concept of any other health check. So we might want to use an uptime check for a virtual machine, a Google App Engine service, a public website, and potentially other things. So the point is we want to be able to see if something's there. And it's just like a load balancer health check. And I'm pretty sure I showed you load balancer health check throughout the program, but I can map this out one more time for you to make sure everybody gets this concept of uptime checks. Bear with me 1 second. I'll whiteboard it out. So what we're really doing here is we basically have an environment, and we've got some sort of a environment. I'm going to call it a server, and it's going to send a check. Hey, is service up and operational? And if it is, it's going to send a response back, operational. And then it's going to say, send a check, recheck. Are you operational? And then if it is, it'll get a response back. So that's kind of the concept of a health check. Now, if we start not getting responses back, send a message and no response, send a message and no response, send a message and no response. Well, at that point, if it's a load balancer, it'll mark it as unhealthy or dead or whatever and send traffic to other servers. If it's DNS, it would do the same thing. Now, here we know there's a problem. Now, if this is an application that's down, for example, that's critical to our business, we know to go to fix it. And we know to fix it fast without losing business. So that's what we're talking about. It's going to help with error handling and incident response, because you're going to know things that are broken where you might not even know something's broken without this kind of thing. So when a device fails to respond, the lack of response can trigger an incident analysis workflow or tell you something's broken. Now, we've got these uptime checks. Now, why wouldn't we want to set up alerting? So we can set up an alerting policy. So, for example, we can have an alert policy that triggers after 3 consecutive failures of a health check. So, or of an uptime check. So, are you there? No. Text message to systems administrators or the app or whoever the operations people are to go fix this, or at least look into this. So, We can have a page and on-call person. We can generate a ticket automatically, even with diagnostic details, depending upon how we set it up in a trouble ticket system. We can fail over to another server, or we can do some type of automated response to mitigate the issue. So we've got an uptime check, and we can do something to respond to it. That's the whole point. So if we look at metrics and alerts, I want to talk about metrics are going to be collections of measurements that are going to provide insights into how your application and services are performing. Now, there are lots of predefined metrics. There's about 1,500 of them or more. So, the point is there's even metrics for other cloud providers, third-party services, even AWS, those types of environments. And we can, some examples of metrics might include request latency to a service, the amount of disk space availability on a virtual machine, the number of tables potentially in a relational database. Regarding metric metadata, it typically is going to include the source of the measurement, the timestamps, and the exact values of the measurements we're talking about. Now, of course, we can do custom metrics as well. And we can create custom metrics at the platform, application, or service level. And therefore, we can track various key performance indicators like availability requirements or performance requirements or bottlenecks in an application, or where we need to optimize code, those types of things in our code. And we can set up, this helps with our SLOs, our SLAs or SLIs, whatever you want to call it. And realistically speaking, we can define what our availability or performance targets are. And these metrics will check the availability and it'll help us get there. So this is going to give us some information of the service level indicators that we're actually there. What is the performance? We need to design 99.99. Are we getting there? Or we need to design 99.99. Are we getting there? So whatever that may be. Now we can set up alerting policies with our metrics as well. We can get something that tells us of system performance degradation, for example, or we can specify an alerting policy based upon the conditions. So if something happens that breaches a metric threshold, DRAM goes beyond a certain thing, we can, for example, get information. We can determine how we want these notifications to be communicated. Do we want to text them, email them, notify a third party? And all this information is going to really help provide detailed information that we can document what happened and what we need to do to improve things in the future. And we can figure out what are the triggers of an alert. So when an alert, something exceeds a policy, and cloud monitoring will show cloud monitoring will show an event notification in its console. And it'll kick off notifications, whoever need to be for the defined people or services in the policy to help, with this normal workflow.
Okay, well, we had our first, I guess it's our 8th day, wow, of the Google Professional Cloud Architect certification, and we've come to a close for the day. Tomorrow is going to be the last day. Tomorrow, I think you have a couple more labs, don't you, Leo?
Unfortunately, no, Mike. The last lab was today.
Okay, the last lab was today, so that means tomorrow is all the academic, all the geekiness, which means I'm on tap all day long, which is totally fine. This is the kind of stuff I love talking about. If you haven't told, I worked on my first cloud in 1993 in some way, shape, or form. It was the ISDN cloud, then the frame relay cloud, then the ATM cloud, then the VPLS cloud, then the BGP 2547 cloud, and then all these clouds that I've helped design and help build private clouds. So I love cloud computing. It's been the story of my life for the last 30 years. So give me a hashtag cloud architect, or give me a hashtag Google Professional Cloud Architect, or give me something that I know you enjoyed the day. Maybe give the video a like, maybe subscribe to the channel, and I hope to see all of you tomorrow on our How to Become a Cloud Architect webinar. It'll be at 11 a.m. It'll be on Zoom. It's normally later in the day, but tomorrow's it'll be 11 a.m. on Zoom because of the boot camp. We'll get in, we'll talk about the role, we'll talk about the skills, we'll talk about how to get hired when you lack experience, what it is that employers truly care about versus what people think they care about, the real skills, how to stand out, and then you can ask me any questions, and it's all free. So hope to see so many of you in the webinar tomorrow. Have a great night, everybody. Leo, thank you so much for your help, and we will see you tomorrow. Take care, everyone.